In 1952, Boeing took a huge gamble by developing a prototype jet transport aircraft, risking more than the company's entire net worth on the project. Had the new aircraft failed, it could have led to the company's downfall. However, the 707 family ultimately became one of the greatest success stories in the history of air travel. On May 15, 1954, the Boeing 367-80, now famously known as the Dash 80, was unveiled to an enthusiastic crowd of employees and guests. Despite the setbacks the British had faced with the jet-powered de Havilland Comet, interest in Boeing's project remained strong. Everyone present understood the significance of the event, though few realized they were witnessing the debut of one of the most important aircraft ever built. The Dash 80 was designed as a one-of-a-kind prototype to demonstrate the viability of jet-powered transportation. Drawing on their experience with jet bombers, Boeing's engineers created an entirely new aircraft. Featuring a wing with a 35-degree sweep similar to military jets, but far more rigid. The wing flaps were divided to prevent interference from engine exhaust. Two sets of ailerons were installed, one for high-speed cruising and the other for takeoff and landing. The Dash 80 featured a tricycle undercarriage, with two sets of main wheels that retracted into the fuselage and a double nose wheel. Powered by 4 Pratt & Whitney JT3 turbojets, which were the civilian counterparts of the engines used in the B-52. These engines were mounted in individual pods positioned below and ahead of the wings. This configuration not only improved weight distribution, but also made maintenance easier. The hinged side panels of the nacelles provided convenient access to the entire engine. Taxiing trials started almost immediately. But on May the 22nd, the Dash 80 encountered an issue when its port undercarriage collapsed. While the structural damage was minimal, the incident delayed the test program by 6 weeks for repairs. The Dash 80 measured 127 feet in length, with a wingspan of nearly 130 feet. Its cockpit was designed to hold a pilot, co-pilot and navigator, but the cabin did not feature standard passenger seating. As a purpose-built experimental aircraft, it had very few refinements. The fuselage interior was virtually bare and featured few cabin windows. Boeing had invested 2 years of secret development into the aircraft and had a clear vision of what they wanted to achieve. Tex Johnson, Boeing's senior test pilot, was selected to fly the Dash 80 on its much-anticipated maiden flight, which took place on July 15, 1954. As the crew worked through their checklists, they carried the company's future on their shoulders. In theory, both military and civilian markets held great potential for the aircraft. However, Boeing had been cautious and slow to enter the commercial market, partly due to resistance from both the traveling public and airlines toward jet airliners. Additionally, Boeing was heavily focused on the development and production of bombers. With the Dash 80, Boeing not only committed to the commercial market, but also gained a significant advantage over its competitors. Boeing's board made the decision to build the aircraft on April 22, 1952, convinced that the US Air Force would eventually need jet transports. They believed that a well-designed jet could serve both military and civilian markets. Powered by 4 turbojets, the Dash 80 lifted off after using just 2,100 feet of runway. Johnson, the test pilot, later remarked that the plane wanted to climb like a rocket, and he had to throttle back to stay within the airspeed limits for the maiden flight.
After flying the B-47 and the B-52, there was no doubt in my mind that the aircraft of the future, military and civilian transportation, was going to be jet. Of course, the prototype 707 was all built with company money, and it was a big responsibility. It was a gamble to some degree from a structure standpoint and a performance standpoint, but not nearly as much as the gamble of how long was it going to take the airlines to decide that's what they wanted and come up with the money to produce it.
Tex Johnston, chief of flight test for the Boeing Airplane Company, signed for the new jet transport and climbed aboard with Dick Flesh, his co-pilot.
With half of Seattle out there observing it, and all of the industry, airlines, engine manufacturers, competition looking down your throat, you had a lot on your mind. But once you fire up the engines and taxi out for takeoff, all that leaves you, and you're primarily absorbed in all the systems in the airplane, how it's reacting to the control. And as we taxied out, the people were jumping up and down, waving, and it was a celebration.
We're clear to come up on power.
We gave it the power, it took off, it rotated, and the first liftoff, the airspeed just kept building. I kept pulling the nose up, and we were light, relatively light, and we were climbing steep. And my co-pilot, Dick Flesh, said, "Man, is this thing going to climb straight up?" And after I landed, some of the engineers said, "We thought something was wrong with the control system. The airplane was climbing so steep. All I was doing is keeping on the best climb speed."
Flight test period, start. We've been climbing for 8,700 feet. All engine operation is normal. Hydraulic pressures are normal. The airplane feels good. The airplane taxied in, and when it had been parked, the pilot and co-pilot were congratulated by William M. Allen, president of the Boeing Airplane Company.
I could see the difference in that man from he shook hands with me before I climbed aboard on the initial flight. And to me, it looked like he was carrying a bit of he was stooped a bit at a load he was carrying, mentally, financially. When we landed at Boeing Field and he came out there, he was standing straight and tall and smiling, and it was beautiful to witness the difference in the man. IATA, the International Air Transport Association, which includes all the airlines of the world, had assembled in Seattle for their annual convention. And Boeing just happened to have a prototype airplane that was going to shrink the world by a factor of 2. But I've sold fighters and commercial airplanes, and you demonstrate them to impress people what they're capable of. And I knew that the prototype, and there's one maneuver that you can do with no hazard whatsoever. I decided that I would do a roll to impress the people. So I came across and did a chandelle. One of my test engineers happened to have his camera with him, and he snapped a picture, which is famous today, with the airplane on its back, the engines up on top of the wing, and the Lake Washington below. I was called to Mr. Allen's office Monday morning, and Mr. Allen asked me what I thought I was doing, and I said I was selling airplanes. And explained it's a 1G maneuver, and it's absolutely non-hazardous, but it's very impressive. And his comment was, "You know that now, we know that, but just don't do it anymore." So it was fine.
The first test, which was smooth and uneventful, lasted only an hour and 24 minutes. In the next 8 days, the aircraft logged a total of 15 hours and 46 minutes of flight time. As the speed and altitude capabilities of jet fighters and bombers increased, They were forced to slow down and descend when refueling from piston engine transports. It didn't take long for the USAF to assess the Dash 80 and recognize its potential as a refueling tanker. Air-to-air refueling had become increasingly crucial, especially with the expansion of the jet fighter fleet during the Korean War, and the existing piston engine tankers were clearly insufficient. The need for an all-jet tanker was apparent, and the Dash 80 arrived at the perfect moment. Just 3 weeks after the Dash 80's first flight, and before it had even been tested as a tanker, Boeing received a contract from the USAF for 29 aircraft. This contract provided a significant morale boost for Boeing, especially since there had been little interest in the civilian variant at the time. The Dash 80 was soon equipped with a modifying flying boom, and a successful refueling test program quickly commenced. On October 5, 1954, the military version of the aircraft was officially designated the KC-135A when the contracts were finalized. Although the initial military order was relatively small, the potential was vast. In late 1953, the USAF had already begun seeking proposals to supply the Strategic Air Command with a jet tanker fleet to extend the operational range of its B-47 and B-52 bombers. 6 companies had been invited to make formal submissions. The USAF tender actually called for the provision of 800 tankers. The stakes for Boeing were immense. While the Dash 80 continued its test flights, production of the KC-135A began at Boeing's Renton factory. Though it was impossible to predict at the time, the KC-135A would remain in production for the next 10 years, with 732 units built in total. The KC-135A models were all equipped with upgraded Pratt & Whitney J57 turbojets and had an impressive fuel capacity, with up to 21 fuel tanks. The aircraft could also transport up to 160 troops or carry 83,000 pounds of cargo. Recognizing the strategic importance of polar regions, Boeing produced a specialized version of the KC-135A for Arctic operations. This version was designed to allow the crew to live aboard for weeks without needing ground support. Featuring a living area, bunks, and food storage facilities. The first production KC-135A Stratotanker was rolled out at Renton on July 18, 1956. The basic design of the KC-135A remained largely unchanged from the Dash 80 prototype, with the same overall dimensions. The first KC-135A tanker took flight on August 31, 1956. After undergoing initial testing, it entered service with the Strategic Air Command by mid-1957. The Stratotanker was notable for its lack of windows and its boom operator's station, with the high-speed refueling boom neatly mounted beneath the rear fuselage. As a military aircraft, the KC-135A was built to meet performance and safety standards that differed significantly from those required for civilian aircraft. Its J57 turbojets, equipped with water injection for additional thrust, produced intense noise and thick sooty smoke during takeoff. With a gross takeoff weight of 316,000 pounds, the KC-135A required a runway length of 13,600 feet, much too long for civilian airports. The KC-135A's airframe was constructed from a different alloy than the commercial variant. Its refueling system, the flying boom, was a Boeing innovation. The boom itself is 27 feet long and extends up to 46 feet, made of concentric tubes. The boom operator, positioned in the tanker, controls the docking process by maneuvering the boom into place. Once contact is made with the receiving aircraft, fuel is pumped from the KC-135's tanks through a series of valves and a pressure regulator, then into the boom and finally into the receiver. Standard speed booms could be swapped out for high-speed versions, designed to refuel faster aircraft like the SR-71 Blackbird. Boeing's contract with the Air Force gave the company the confidence and financial stability to further pursue the profitable civilian market. Pan American became Boeing's first 707 customer when it placed an order for 20 aircraft in October 1955. To Boeing's delight, Pan Am also ordered 20 Douglas DC-8s on the same day, even though that plane wouldn't fly for another 3 years. The inaugural 707 airline service was launched on the 26th of October 1958, when Pan Am flew 111 passengers from New York to Paris. Soon after, American Airlines launched the first scheduled passenger jet service from Los Angeles to New York. This cut the flight time across the US to about 4 hours, effectively halving it. In the first 18 days of operation, American Airlines transported 3,720 passengers, achieving an impressive load factor of 99.5%. The use of doors at both ends of the cabin allowed for quick boarding and disembarking, a significant advantage that necessitated changes in airport design and operations. The initial 707s were designated as the 707-120. Although the 120 model was primarily designed for domestic routes, Pan Am used it for transatlantic flights. The cabin could accommodate 121 first-class passengers or 179 in economy. With the introduction of longer-range 707 models, most of the 120 series aircraft were reassigned to domestic services. The 707's spacious fuselage and excellent performance quickly won favour with both passengers and crew. Its ability to fly above weather conditions, which propeller-driven liners had to navigate through, offered smoother, faster and safer flights. The cabin of the 707 could accommodate twice as many passengers as the older Constellations, making air travel a viable option for a growing number of travellers. Jet travel not only displaced competition from propeller-driven aircraft, but also heralded the decline of passenger ships, which even into the 1960s carried more travellers than holidaymakers. It's no exaggeration to say that a transportation revolution had begun. The competition soon intensified, with the emergence of the Douglas DC-8, the Convair 880, and various European models. Boeing was compelled to initiate a program to develop even more advanced jetliners. The initial risk of $15 million had been far surpassed, with new stakes approaching $100 million. Although Boeing maintained a significant production lead with the 707, Douglas gained traction with the DC-8 by promising greater payload capacities, longer range, more powerful engines, and other benefits for airlines and passengers. While Pan Am and American Airlines operated the 707-120, Boeing was already working on another important version of the aircraft. In response to the Douglas challenge, Boeing had announced the development of a new 707, offering greater range and capacity, the intercontinental 707-320. In a hydrostatic test tank, the fuselage of the intercontinental 707-320 was subjected to conditions equivalent to 40 years or 50,000 flight cycles. During testing, the fuselage was intentionally torn open and then subjected to cycles of extremely high pressures and heavy loads. Despite this, the damaged structure endured the stress without sustaining further structural damage. The 707-320 made its first flight on January 11, 1959. The success of the test series was so significant that just 35 days later, the aircraft was handed over to the Federal Aviation Agency, FAA, for certification trials. At Edwards Air Force Base in California, the Intercontinental underwent rigorous testing. It wasn't allowed to carry passengers until it received a certificate of airworthiness from the FAA. FAA test pilots conducted a thorough evaluation of the aircraft's flying characteristics, while ground engineers measured the performance of every component. The test team pushed the aircraft to its limits, flying it at altitudes ranging from low levels to the stratosphere, and at speeds from near stall up to 700 miles per hour. The Intercontinental 707-320 was over 12 feet longer than the 707-120, and featured a wingspan nearly 12 feet greater. It was the first model to be truly intercontinental, directly challenging the claims made by Douglas for the DC-8. Equipped with powerful Pratt & Whitney JT4 turbojets, the aircraft was capable of carrying a payload equivalent to 189 passengers. One of the final FAA tests involved installing ballast tanks in the cabin, filled with water to simulate the weight of 180 passengers and 45,000 pounds of payload. An additional 9 tons were added for extra measure, bringing the total weight of the aircraft to 316,000 pounds, a significant challenge for the FAA team of pilots, engineers and technicians. On the test day, conditions were ideal for a maximum weight takeoff, and the powerful turbojets required only 2/3 of the runway to lift the Intercontinental into the air. The 707-320 was also offered with the Rolls-Royce Conway Mark 508 turbojet as an engine option. BOAC was among the first to choose this engine, partly because it was a British product. The decision to purchase a 707 instead of a British aircraft had political implications. During the trials for its British certification, several extensive modifications were required, including a taller fin and a power-assisted rudder. These changes were later incorporated as standard features on the production line. The final test flight, conducted under full airline operating conditions, marked the first truly intercontinental flight of the jet age. The Intercontinental 707-320, sporting its new Boeing livery, was destined for Rome, Italy. William Allen, the chairman of Boeing, had good reason to smile. After departing from Boeing Field in Seattle, the 707-320 took a northeast route along the Great Circle Path. It flew over Canada, Greenland, Scotland, and Germany, cruising at Mach 0.78 and reaching a maximum altitude of 39,160 feet. The aircraft landed in Rome just 11 hours and 6 minutes after takeoff, marking the longest flight ever completed by a jet airliner up to that point. The following day, the plane continued its journey to Paris, Frankfurt, and Brussels before making a night stop at Heathrow. The FAA granted certification on September 23, 1958, and the transport revolution advanced further. By the end of 1958, Boeing's Renton plant was producing aircraft for airlines in 11 nations. In addition to the standard 707 models, they were preparing for both the intercontinental versions and new high-speed developments. This variant would eventually be distinct enough to earn its own identity as the Boeing 720. Different versions of the aircraft were assembled simultaneously, with airline labels providing clues to their destinations. For instance, South African Airways and Varig of Brazil had orders for the Intercontinental 320, while a version for Lufthansa was equipped with Rolls-Royce Conway engines. This particular version gained popularity and was marketed as the 707-420. As production ramped up, 707 milestones were achieved rapidly. The 100th 707, adorned in the livery of Air India International, was also a 707-420. By the end of 1959, the medium-range 720s were being delivered to United Airlines. In total, 154 of this model were built in 2 different versions. Lufthansa flew back to Germany in record time. Sabena began operating 707 services to Africa and Russia. The 720 model achieved a speed of Mach 0.9, just as the designers had promised. A Rolls-Royce-powered Intercontinental 707 made history for BOAC by completing the first non-stop crossing of the North Pacific, flying from Seattle to Tokyo. Air France introduced the Model 320 on transatlantic routes, while Braniff launched a special tropical version of the aircraft. The new jets were so well received that, until sufficient numbers were in service, they were often filled exclusively with first-class travellers. Within a year of entering service, the 707 had carried over 2 million passengers. Australia's Qantas launched a new service from Sydney to San Francisco, one of many new routes established worldwide with the introduction of Boeing's aircraft. Despite significant pressure to purchase British aircraft, Qantas opted for the 707-120. Boeing had designed this short-bodied version specifically to allow Qantas to operate from Sydney's short runway, as well as the short runways of its Pacific stopover destinations. The longer routes, typically flown by Qantas, meant sacrificing some passenger capacity in favour of enhanced performance. This trade-off was more than compensated by the plane's improved range and speed. Although only 7 of these aircraft were built, they proved to be a great success. Qantas passengers experienced the Pacific Ocean journey reduced to just 15 hours. Production of the 707 series concluded in 1979. With a total of 917 aircraft across all versions built. These jets were operated by 62 different airlines, and in at least 300 of them are still in service today. One of the most definitive signs that the jet age had arrived occurred in December 1959, when a United States Air Force 707, the C-137A, landed in Rome. The jet, carrying President Eisenhower on a mission dubbed Operation Monsoon, was used for a whirlwind tour of 11 countries in 19 days, a journey that would have previously taken over a month. In Turkey, the president was welcomed by more than 400,000 people. In India, Eisenhower fulfilled one of his dreams by visiting the Taj Mahal with President Nehru. And upon arriving in Athens via Tehran, he had traversed the entire empire of Alexander the Great in just 1 day's travel. The president's journey continued through France, Spain, and Morocco before returning to the United States. The trip was a resounding success, with massive crowds welcoming him at each stop. However, its significance extended beyond diplomacy. For millions of people, it marked the beginning of a new era in global travel. Package tours have since become a common way for people to experience the world, echoing Eisenhower's journey. For Boeing, the mission highlighted the critical role of the 707. Although the military had its own version, the C-135, the USAF also acquired civilian 707s, which were designated as C-137s. The 707s replaced the Air Force's small VIP fleet and served as presidential transports for every president from Eisenhower to Reagan.
Thank you very much indeed for coming out on this cold night to welcome my party and me back home. It's certainly good to be here. Now, I must remind you that this morning we had breakfast in Madrid, our lunch in Casablanca, and now we are home at an hour which, by our getting up time, was 5 or 6 o'clock in the morning. So you can realize that this is not a time for a very erudite and informing speech.
These planes have become historical icons in their own right. For instance, one aircraft served as Air Force One from 1962 to 1972. Its most sober moment occurred when it was used to return the body of President John F. Kennedy to Washington after his assassination. The designation Air Force One has since been assigned to other aircraft, and it's the radio call sign used only when the president is on board. The VC-137s were operated by the Air Transport Wing. Each was configured with a custom-built interior, luxuriously equipped with only 22 seats. The C-137s were equipped with advanced navigation and communication systems to ensure global self-sufficiency. By 1989, presidential duties were transferred to a pair of Boeing 747s. In contrast to the limited number of C-137s, a substantial fleet of C-135s was produced. Many of these airframes have been extensively reconfigured and used in a wide variety of roles by different branches of the military. During the Vietnam War, the C-135 series was particularly prominent, with up to 10 different variants in operation simultaneously. Several C-135s were modified to carry electronic communications and intelligence equipment under the Strategic Air Command. The EC-135s, which served as airborne command posts, played a crucial role in the air war. These aircraft were originally designed for other purposes, but were adapted to the EC-135 standard.
The EC-135 aircraft looks like just about any other C-135 series aircraft in the Air Force inventory. The big difference is in the back. This is the SAC Airborne Command Post, known as the Looking Glass. The Airborne Command Post is a scaled-down version of SAC's primary underground command post and has the same basic capabilities. On a day-to-day basis, the underground command post controls SAC's forces around the world, but it would be a primary target for a potential enemy during wartime. If the underground command post is disabled, control of SAC's forces passes to the Airborne Command Post. Its battle staff is trained to manage any counterattack the President may direct and to direct the recovery of returning bomber and tanker forces. There's an Airborne Command Post flying over the Midwest 24 hours a day. Additionally, the Looking Glass aircraft has the capability to launch the Minuteman missile force if primary launch control centers are disabled.
The Looking Glass planes, a notable example of the EC-135s, were particularly significant.
Yeah, we're about ready to take off. Communications is the key element in maintaining command and control of the forces. Looking Glass is equipped with radios covering a wide spectrum of frequencies and includes the Air Force satellite communications system. At the touch of a button, the battle staff can talk to any SAC base around the globe.
An EC-135 designated Looking Glass was operated by a crew of 16.
Attention battle staff, Major General Buckman is on board the aircraft.
The EC-135s were equipped to remain airborne indefinitely, featuring both reverse fueling capabilities from SAC bombers via the boom and a standard refueling point. Each EC-135 was staffed by 5 flight crew members, 10 additional personnel, and a very senior officer. Over their service life, the EC-135s have been adapted into 8 different versions, reflecting their crucial roles and the special care given to their maintenance.
There's certainly been a lot of changes in the Looking Glass as far as the equipment and the performance of the aircraft over the past 21 years. But the basic vision to provide a survival command and control element has not changed. I think the great achievement is that it's been airborne continuously for 21 years, and that's due to a lot of dedicated people. We have outstanding air crews, battle staff, but mainly the people who supported on the ground have allowed this to happen. Primarily the maintenance people. They have to be out here 24 hours a day to ensure that we maintain this record and we can meet our commitments.
Although they were first produced in the mid-1960s, many EC-135s remain in service today. Notable milestones in their service include providing tactical command during the 1986 raid on Libya, confirming the Chernobyl accident through intercepts of Russian communications, and playing a key role in the Gulf War. In the late 1960s, the USAF awarded Boeing a contract to convert 2 Series 320 civil airliners for military use. Upon completion, there was no mistaking the EC-137s, as both were equipped with a distinctive 30-foot diameter rotating antenna mounted above the rear fuselage. These aircraft were the first 707-based AWACS planes, Airborne Warning and Control System. The AWACS were designed to function as a combination of a radar station, communication center, and command post. They were mobile, flexible, survivable, and resistant to jamming. With their capability for long-range surveillance in all weather conditions and over all terrain types, AWACS have become a crucial component of Western defense systems. As AWACS, the military 707s have truly demonstrated their capabilities as aerial sentries. A supersonic jet traveling at twice the speed of sound would move only 1/8 of an inch in the time it takes a laser beam to travel 1 mile. At the Air Force Weapons Laboratory in Kirkland, New Mexico, an airborne laser laboratory has been established. This aircraft was converted from an early KC-135 production tanker and is equipped with a distinctive narrow hump on top of the fuselage, which houses a rotating turret at the front. The turret, measuring 5 feet in height and weighing around 4,000 pounds, is a key component of the system. The turret is capable of rotating at about 100 degrees per second. The Airborne Laser Laboratory, operated by the 49th and 50th Test Wings, utilizes carbon dioxide laser technology to test its effectiveness on various materials used in aircraft construction. Engineers and scientists who developed the high-energy laser program are on board, allowing them to operate and refine the equipment they conceived, designed, and built. This airborne laboratory is another example of the diverse roles and configurations the 707 family has undergone over the years. Since the mid-1960s, the USAF has continuously maintained and updated its KC-135 tanker fleet. A significant upgrade for these tankers was the installation of fuel-efficient fan engines, which provided greater thrust and instant start capability. The re-engined KC-135s benefited from a 30% increase in thrust, coupled with a 27% reduction in fuel consumption, 85% less noise, and 90% fewer emissions. These advancements also extended the aircraft's lifespan. Alongside the new engines, the electronic, hydraulic, and flight control systems of these updated tankers were also modernized. Among the various unique variants of the 135 series are reconnaissance aircraft featuring a distinctive thimble-shaped nose. This bulbous nose houses sensitive radar equipment, and many of these planes are also equipped with camera ports and fuselage antennas. These aircraft play a crucial role in ongoing intelligence collection. Even more unusual were the 8 EC-135Ns, which had an even more pronounced nose deformation to accommodate a 7-foot diameter dish antenna. Converted in 1967, these planes were crucial to the Apollo projects. Operating in pairs, they ensured continuous voice communication between astronauts and ground control during manned space flights. In addition, they assisted in tracking the spacecraft. Despite the numerous innovative variants, the KC-135 tanker remains the cornerstone of the 135 series. Since the re-engineering program began in 1980, the operational benefits have been significant. The re-engined KC-135RE alone saves up to $400 million annually for the USAF due to reduced fuel consumption. Enhanced fuel efficiency allows these aircraft to offload more fuel, as they require less for their own needs. In addition to the re-engineering, 33 major modifications have been made to enhance strategic readiness. These upgrades have reduced maintenance needs, enabling crews to deploy more quickly. Around the clock, every day of the year, KC-135 crews are on alert globally. During the 1986 raid on Tripoli, the tankers were crucial. They refueled the F-111s at least 4 times on their way to Libya and twice on the return journey. This capability was vital, as both Spain and France had denied the United States overflight rights. In addition to the tankers, an EC-135E provided tactical command for the raid, and another C-135 was tasked with delivering photographic evidence back to Washington. During Operation Desert Storm, both US and French KC-135s played a crucial role, providing in-flight refueling for all US aircraft as well as several Allied aircraft. The updated KC-135s, equipped with powerful new turbofan engines, benefited from a substantial increase in thrust. This improvement allows these aircraft to take off with a full load from a distance up to 2,500 feet shorter compared to earlier models. The maximum takeoff weight has been increased to 322,500 pounds. The efficiency of the new fan engines translates into significant operational benefits. The aircraft can offload 65% more fuel at a 1,500-mile radius, and an impressive 150% more at a 2,500-mile radius. Currently, the average C-135 airframe has utilized only a third of its expected 30,000-hour lifespan. There seems no doubt that the jet will still be in service beyond the current plans for their retirement around the year 2020. In 1972, the Dash 80 was retired and donated to the National Air and Space Museum. It remained in storage in the Arizona desert for 18 years due to a lack of exhibition space. The Dash 80 had been a pioneer in modern jet transport and a testbed for new aircraft and engines. In 1990, the aircraft was brought out of storage for a final restoration. A dedicated crew undertook the meticulous task of returning the Dash 80 to flying condition, checking and rechecking every rivet and overhauling the old Pratt & Whitney turbojet engines. After the extensive refurbishment, the Dash 80 was prepared for its final flight back to Seattle, the city where its groundbreaking journey began. The Dash 80's final flight to Seattle was a significant event. Piloted by Paul Bennett and co-pilot Jerry White, the aircraft made a stop at Moses Lake, Washington, to pick up a group of distinguished guests and longtime admirers. The restoration of the Dash 80 had been a major effort, involving 15 technicians and engineers working a total of 1,000 man-hours. Among the notable passengers was Tex Johnson, the senior test pilot who'd first flown the Dash 80 over 35 years earlier. The Dash 80's preservation is indeed a fitting tribute to its historical significance. By using dry ice for paint stripping, Boeing not only ensured that the aircraft's restoration was environmentally friendly, but also highlighted the ongoing innovation in aviation technology and practices. Restoring the Dash 80 to its original livery and showcasing it in the Boeing Museum of Flight honors its pivotal role in the evolution of commercial aviation. It serves as a living testament to the advancements and milestones achieved in the industry thanks to the Dash 80's pioneering efforts. The Dash 80's legacy is a powerful reminder of the impact that a single aircraft can have on an entire industry. Its journey from a groundbreaking prototype to a symbol of aviation's golden age illustrates how innovation can set the stage for a monumental change. Boeing's transformation from a minor player to a dominant force in civil aviation is a direct result of the Dash 80's pioneering role. The aircraft's recognition as one of the Smithsonian's most important aircraft highlights its enduring significance in the history of flight. The Boeing 707 indeed transformed the aviation industry, turning air travel into a feasible option for millions of people and shrinking the world in unprecedented ways. Its role in both civil and military aviation is a testament to its design's versatility and impact. Its robust design ensures that it will remain a fixture in the skies, a lasting symbol of the jet age and the innovative spirit of the 1950s. In 1966, the aviation community celebrated the remarkable contributions of British aviation pioneer Sir Frank Whittle to the industry. A quarter of a century earlier, this visionary aeronautical engineer had revolutionized air travel with his groundbreaking invention of the jet engine. On May 15, 1941, an experimental Gloster E-2839, powered by Whittle's W1 jet engine, soared into the skies above Cranwell, flying for 17 minutes and achieving a top speed of 545 kilometers an hour. By the war's end, the Gloster Meteor had shattered world speed records, reaching an astonishing 975.46 kilometers an hour. Sir Frank Whittle, alongside German inventor Hans von Herrhein, accelerated the evolution of jet aircraft, making them the preferred choice for long-range travel in just a few decades. While the 1930s epitomized luxury in air travel, the 1950s witnessed a surge in faster and more affordable flights, democratizing air travel for countless individuals. Whittle's groundbreaking achievements propelled British aerospace to the forefront of the aviation industry. American companies concentrated on piston engine airliners, leaving the field free for the British to race ahead with jet technology.
Once again, the eyes of the world turn to Britain as aircraft manufacturers stage the greatest flying show on earth at Farnborough in Hampshire.
By 1952, Britain was experiencing a surge of national pride, fueled by its rapid advancements in jet technology. The pinnacle of these achievements was showcased at the prestigious Farnborough Air Show, featuring standout aircraft such as the Supermarine Swift, the Gloucester Javelin, and the Handley Page Victor, alongside tantalizing glimpses of future airliners.
The Bristol Britannia, a turbojet capable of carrying 104 passengers, will soon be in regular service. Now the Victor, Britain's crescent-wing bomber. Powered by 4 Sapphire jet engines, it's already in super priority production for the RAF. Few details have been released about the Victor, but there seems little doubt it's intended as Britain's #1 atom bomber. Huge delta-wing Avro Vulcan. Britain pioneered and perfected the delta-wing design. Now the flying darts, Avro 707s, the fighters from which the Vulcan was developed, form up in escort. Farnborough, our showplace of the air, proves once more that Britain is leading the world into this new jet age. As we looked at the latest aircraft that have swept Britain to the forefront of aviation.
However, the journey wasn't without its challenges for Britain's high-performance jets. During the air show, pilot John Derry was demonstrating the capabilities of the de Havilland 110 fighter. Just 4 years earlier, Derry had made history as the first British pilot to break the sound barrier in a British aircraft.
But those who watched during those 5 days could never know the feelings of the men whose job it was to take an aircraft through the sound barrier again and again. And perhaps as we thrilled to their daring, we almost forgot that on each and every flight, death flew with them. But those who were there on the 6th day will never forget. For it was on that day that a fault developed in Derry's black aircraft, and he and his observer flew in another. The aircraft broke through the sound barrier and then flew low over the airfield. Now the split-second disaster in slow motion.
Tragically, as Derry initiated a climb, the wings of the aircraft failed, causing the engines to detach and plummet to the ground. While one engine landed without incident, the other crashed into a crowd of spectators, resulting in devastating consequences, killing 29 people and many more were injured. An investigation found that the de Havilland's D-nose leading edge arrangement was unsuited to the stresses of supersonic flight in such a heavy aircraft. The tragic incident prompted a widespread overhaul of safety regulations governing airshows.
The heavy death roll is mute testimony of the dreadful tragedy. Almost at once, Derry's friend Neville Duke flew a Hawker Hunter through the sound barrier again. Flying, like progress, must not stop. John Derry was an explorer in an unknown world, whose barriers can only be penetrated by such men as he. Their courage and skill have won us great victories in the skies, and they will go on.
In the years following World War II, Britain's aeronautical industry thrived. The Vickers VC-1 Viking exemplified a new era of passenger aircraft design. Derived from the Vickers Wellington bomber, this twin-piston engine short-range airliner served airlines worldwide for many years. Crucially, for jet propulsion development, a modified Viking equipped with Rolls-Royce Nene turbojets emerged as Britain's first pure jet transport aircraft in 1948. However, the initial British passenger jets introduced into service were powered by turboprop engines. With the Americans focused on piston engine airliners, the British enjoyed a wide open field for advancement with the release of the Vickers Viscount and the Bristol Britannia. Turboprop engines harness the high-temperature gas within a jet engine to propel the propellers, delivering superior power and speed compared to piston engines, along with enhanced fuel efficiency compared to turbojets. Advancements in technology elevated support roles to a more technical level.
For example, to keep each airliner in the air today, over 100 workers are needed on the ground. But the safety of operations also depends upon the proper maintenance of planes. For this reason, many skilled mechanics must be employed. Their work is highly specialized, and those who direct or supervise such work must hold a federal government certificate and ratings depending upon the type of work they do. For example, mechanics qualified to supervise work on general maintenance, including dismantling, welding, or fabricating, must hold what is called an A, or aircraft certificate. Others, who supervise and approve engine work only, are required by the Civil Aeronautics Authority to hold an E, or engine certificate. But no matter what their chosen field may be, regular apprenticeship courses or equivalent technical schooling is required.
BOAC, Britain's premier airline, leveraged turboprops throughout the 1950s, exploiting their increased power and range to pioneer non-stop global flights.
Emerging from the war with tremendous military air strength, but little civilian, our airlines have since then been striving to make up for lost time. Informed observers of the British aviation scene believe that the United Kingdom has two trump cards to play in her bid for leadership in the sky. The bold, far-sighted policy of executives like Whitney Straight, and her acknowledged genius in the design of new aircraft and engines. They point to Britain's intensive pioneering of gas turbines, prime movers which will outstrip by many hundreds of miles an hour the speeds accepted in present timetables.
Intense competition characterized the aviation market, with nations like France and India striving to offer the most luxurious travel experiences.
For you, the new pleasure of travel in the latest luxury airliners, twice as fast, with personnel whose courteous attention is world famous.
I think we ought to have the lettering much bigger. Air India, the route of the magic carpet.
A diplomat, a movie siren, a world-renowned musician is usually aboard, and maybe sitting beside you. And remember, breakfast in bed.
Britain, committed to leading the aviation industry, introduced the world's inaugural turboprop aircraft in 1948. The Vickers Viscount, a medium-range airliner manufactured at the Vickers factory in Weybridge, epitomised this innovation. Quieter and smoother than piston engine counterparts, the Viscount accommodated approximately 50 passengers and soared to become one of the most favoured airliners. A total of 445 Viscounts were manufactured and distributed to airlines worldwide. Powered by 4 Rolls-Royce Dart Mark 525 turboprop engines, the Viscount boasted an operational altitude of 25,000 feet. Later variants featured a new fuel system, a 2-pilot cockpit, more powerful engines, and increased weight. In 1949, the Bristol Brabazon took to the skies, a 100-seater airliner developed for the transatlantic market. Unfortunately, despite its promising start, the airplane never entered mass production and the prototype was dismantled for scrap. The Bristol Type 175 Britannia turboprop, affectionately known as the Whispering Giant, earned its moniker for its serene and smooth flight experience. Although it made its maiden flight in 1952, setbacks, including the loss of 2 prototypes to icing issues, delayed its official launch until 1957. As a result, only 85 Britannias were manufactured. Yet the aircraft garnered widespread acclaim as one of the finest turboprop airliners ever engineered. BOAC procured 18 of these long-range airliners out of the 312 produced, pioneering non-stop transatlantic flights between London and New York in both directions. Additionally, the Royal Air Force operated several Bristol Britannias, utilising them until 1975, when they were retired from military service and sold to various African, Middle Eastern and European airlines, which operated them until the 1980s. Meanwhile, behind the Iron Curtain, the Soviet Union was making significant strides in jet airliner technology. The arrival of the Tupolev Tu-114 at the Paris Air Show in 1959 astounded Western observers with its imposing size and advanced features. The airplane features swept-back wings at 35 degrees. Its Kuznetsov NK-12 MV turboprops were the most powerful ever made, and its landing gear was exceptionally long because of the huge propellers.
The world's largest airliner with seats for up to 220 people, a range of 6,000 miles, so that it can fly easily from Moscow to New York non-stop. Well, the Russians have been photographing our planes in great detail while they've been here, so now no doubt they're going to allow us the privilege of taking a few pictures of theirs.
The Tu-114 served on international routes until it was surpassed by the Ilyushin IL-62 and reassigned to domestic flights. Later, it was repurposed for military use, operating in the Soviet Army and Air Force until 1991. Despite the efficiency of turboprops in passenger aviation, Britain remained eager to incorporate turbojets into its commercial fleet. In 1952, BOAC introduced the de Havilland Comet, the world's inaugural jetliner and a symbol of British aviation prowess. The American business magazine Fortune hailed 1953 as the year of the coronation and the Comet. Distinct from the clamour of piston engines, the Comet emitted a distinctive high-pitched whine during approach. Cruising at altitudes of up to 40,000 feet, passengers enjoyed pressurized comfort.
Early in the year, a brilliant new all-British achievement made headline news throughout the world. The Comet made its debut on a journey from London Airport to Johannesburg. 4 de Havilland Ghost jet engines power this mighty passenger-carrying craft that the British Overseas Airways Corporation have adopted for their major air services. The Comet was soon airborne for its first historic flight, London to Johannesburg, a journey of more than 6,000 miles. Quickly and smoothly, the Comet climbed to 40,000 feet. At some 500 miles an hour, the Comet flashed over Europe. Always a new land, a new country to be seen, no time to be bored with the journey. Soon the Alps were below. Speed, reliability and comfort, these are among the Comet's greatest assets, backed by BOAC service second to none. Stewardess Audrey Cartmel looked after the passengers. High over Africa it flew, then below, white patches showing where gold had been wrested from the earth told the passengers that they'd reached their destination. This was Johannesburg. The Comet had made the 6,000-mile journey in 23 hours and 40 minutes, less than a day from London. The Comet's achievement thrilled the world and set higher than ever before the prestige of British aircraft and airways in this jet age.
Unfortunately, Britain's aviation future faced unforeseen challenges. In its debut year, one Comet suffered damage and another failed to become airborne due to an issue with the leading edge of its wings. Tragically, worse incidents were to follow. In May 1953, a Comet crashed during a tropical storm just 6 minutes after departing Calcutta Airport in India. Initially attributed to adverse weather, the crash raised concerns. Then, in January 1954, another comet exploded at 30,000 feet en route from Rome to London, marking a devastating turn of events. There was no obvious explanation for the crash, which killed 35 people. Investigators ordered some modifications before allowing the airplane back into service, but they had no real idea what caused the accident. 3 months later, another tragic incident unfolded as yet another comet disintegrated over the Mediterranean. The entire fleet faced an immediate and indefinite grounding, while experts delved into the root cause of these calamities. Leading the investigation was Sir Arnold Hall, a distinguished aeronautical engineer renowned for his contributions, including designing the compressor for Frank Whittle's pioneering jet engine. The Ministry of Civil Aviation constructed a massive tank, spacious enough to accommodate a comet, and filled it with water to replicate the atmospheric pressure experienced at 35,000 feet. Through exhaustive testing, Hall determined that metal fatigue lay at the heart of the comet disasters, stemming from the recurrent pressurization and depressurization of the aircraft cabin. Further analysis revealed that the window supports were punch-riveted rather than bonded, exacerbating the structural vulnerabilities. Consequently, the Comet underwent significant redesign, with the insights gained informing safety improvements across the aviation industry. In a curious aside to the investigation, novelist and aeronautical engineer Neville Shute briefly served at the de Havilland Aircraft Company in the early 1920s, adding an unexpected dimension to the narrative. In 1948, he published No Highway, a best-selling thriller about an aircraft engineer who becomes convinced that a new airliner type is fatally flawed due to metal fatigue. Neville Shute christened his fictional airliner The Reindeer, sparking speculation that the novelist was subtly expressing concerns about the Comet's design in a veiled manner, given the association of Comet with one of Father Christmas's reindeer. In 1951, Shute's book was adapted into the widely acclaimed film No Highway in the Sky, featuring James Stewart and Marlene Dietrich. With the Comet sidelined, the Soviet Tupolev Tu-114 stood as the sole civilian turbojet operating passenger routes. Derived from the Tu-16 Badger strategic bomber, the Tu-104 underwent rigorous pressure testing in a water tank before entering service with the Soviet national airline Aeroflot in 1956. Meanwhile, British firm Avro set its sights on transatlantic markets. On September 1, 1950, Avro unveiled the Avro Ashton, an experimental jet airliner propelled by 4 Rolls-Royce Nene 6 turbojets. Insights gleaned from the Ashton project were integrated into the development of the Avro C-102, manufactured in Canada and marking the first civilian jet aircraft to land in the United States.
In Toronto's Malton Airport, a Canadian Avro jetliner, a 4-jet 60-passenger transport, takes off with a cargo of mail, climbs quickly to 20,000 feet, and heads for New York. "59 minutes later, she zooms over Idlewild Airport, cutting in half previous airline records for the 370-mile trip. The plane, called Canada's idea of a better mousetrap in the aviation field, is the first jetliner to carry international airmail in this hemisphere.
On Rome's Ciampino airfield.
Nevertheless, Britain remained resolute in reclaiming its dominance with a revamped Comet. The government extolled the virtues of the new airliner, investing considerable effort in linking the successes of previous aircraft to the anticipated triumph of the Comet. Mindful of the public confidence shattered by the early Comet tragedies, de Havilland dedicated several years to meticulously refining the new design. Despite pressure to change the name and create distance from the earlier model, de Havilland stood by the brand and by 1957 had produced the Comet Mark IV. The new Comet model underwent a meticulous inspection process, including rigorous pressure testing in a water tank, supplemented by hydraulic rams exerting additional stress on the wings. The setback experienced by the Comet proved to be a fortunate turn for the American aviation industry, which seized the opportunity to bridge the gap with its groundbreaking Boeing 707 jetliner. Derived from the military KC-135 Stratotanker, the 707 boasted 70% more power than the Comet, accommodating 179 passengers and double the fuel capacity. Eager to secure a foothold in the lucrative transatlantic market, the Boeing 707 arrived in the United Kingdom for testing in preparation for launching flights between Britain and the United States.
The biggest, the heaviest, and the fastest airliner flies into London Airport. It's the Boeing 707, America's rival to the Comet 4 in the race to provide the first jet airline service over the Atlantic. The Boeing, its 4 jet engines screened by huge silencers, is here to pass noise tests before it can use the airport. The massive interior will carry 165 economy-class passengers, flying at heights that make individual oxygen supplies necessary for emergency use.
Galvanized by the American competition, de Havilland pressed forward with the Comet. Despite its shorter range compared to the 707, BOAC committed to purchasing 20 aircraft, recognizing that the Comet's ability to operate from existing runways and reach numerous smaller airports along BOAC's routes was advantageous. This marked the beginning of the end for BOAC's piston engine fleet. According to pilot John Cunningham, despite its advanced technology, the new aircraft proved to be more user-friendly than its predecessors.
How does she compare with the earlier Comets?
Well, it's very much more lively, having more than twice the power of the earlier Comets. Its flying qualities are much improved over the earlier Comets, partly as a result of the last 8 years' flying experience on Comets. And generally, I think it's an easier aeroplane to fly than the earlier Comets.
Are you absolutely confident that you straighten out the problems that caused the early Comet disaster?
Yes, absolutely. We've learned an enormous amount, of course, in the last 8 years, and particularly in the last 4 years, as a result of the Comet inquiries. A lot of research and development work has been made on structures, and we have today in the Mark IV an aeroplane that embodies really all the best experience that any manufacturer has had.
The Comet features simplified controls to aid flight crews in managing the increased takeoff and landing speeds. Its inaugural challenge came in the form of the race to conquer the Atlantic. Pan Am was confident its 707 would be the first, but BOAC had a surprise in store.
It was a great race, and Britain won it. Comet 4 Delta Charlie flies into New York, the first jet to carry fare-paying passengers across the Atlantic. And Comet 4 Delta Bravo clinched the victory with a record non-stop west-east flight in 6 hours, 7 minutes on the same day. The first commercial jet service across the Atlantic is established, and BOAC are flying it. For the 28 passengers, it was a great occasion. But for the team who flew her and the men who built her, Delta Bravo's capture of the blue ribbon of the Atlantic Airways was final triumph. Such men as her captain, Tom Story, and the man whose genius created her, designer Tim Wilkins. Mr. Wilkins, you designed a wonderful aeroplane. Have you had much in the way of trouble on the way?
Well, we had, of course, our full measure of troubles, the Comet 1, which was designed some time ago, and was, of course, a very big step forward in the aviation airline business. Anyway, after the troubles, we did decide to carry on with the Comet and retain the name and bring it back.
Comet's story stretches back into the war, when Britain's all-out effort to produce fighting aircraft gave her no chance to develop civil types. But Sir Frank Whittle's first jet engine gave the opportunity to forge ahead again. For 13 years, development of the Comet went ahead at de Havilland's. First, Comet 1 and failure. Then, the bigger, faster, safer and better Comet 4. But America's research was bounding forward, and after the setback to Comet 1, it looked as though the Boeing 707 would be first across the Atlantic. Everyone believed the race had gone to the United States, and Pan American spent an estimated £500,000 advertising the first transatlantic jet service. Everyone believed it except the Havillands and BOAC, and they'd a surprise up their sleeves. Early delivery of not 1 but 3 Comets. And that did it.
more than a month ahead of their own schedule and 3 weeks in front of the Boeing's expected entry into service, BOAC sent off the first regular jet service across the Atlantic. Yes, Comet 4's in business. Britain's aircraft industry can chalk up its greatest post-war triumph.
As well as the Comet 4, Britain was counting on another jetliner to keep it in the forefront of the jet race.
So George, what can the VC-10 do?
Well, the passenger accommodation varies between 108 and 150 people according to the class of layout. Cruising speeds in the 600 mile an hour class. Cruising height between 40 and 50,000 feet according to the length of the trip. The range, London, New York, non-stop.
Why are the engines on the fuselage and not on the wing?
Because the aeroplane has to be better than the American jet, which will be in service some years before it. And the biggest problem in these big jets is aerodrome performance. If you keep the engines away from the wing, so that you've got them pulled back with a clean wing, you can develop a takeoff performance of the aeroplane much superior to the one which you have with the engines on the wing. You have a completely clean, unbroken leading and trailing edge flat, and you get out of difficult aerodromes at greater weights.
What about for the passengers? Is there any improvement for them?
Yes, so there's going to be a big advantage in passenger comfort because the noise and vibration, whatever there is behind them, and forward of that line, say, the interior is going to be pretty quiet.
The VC-10 and the imposing Vickers Vanguard turboprop emerged as heralds of the aviation future.
Mock-up of the Vickers Armstrong VC-10 indicates the shape of things to come in British airliners. The cost of the mock-up is £500,000, showing that building large airliners is a big money business. The VC-10 will carry a maximum of 150 passengers at about 600 miles an hour, the power being provided by 4 Rolls-Royce Conway engines. It will be in the air by 1961. The engineers concerned believe that engines mounted in the rear are best. But the VC-10 isn't the only aircraft built at Weybridge. There's the Vanguard too. Turboprop, twice as big as the famous Viscount, it will fly on BEA routes next summer. The VC-10 could reduce tourist fares by 50%. Roll on the day when it's in the air.
The Vickers VC-10 was slated to revolutionize air travel as the premier large jet airliner equipped with 4 rear-mounted engines. Produced at the British Aircraft Corporation's Weybridge facility, this 150-passenger aircraft aimed to claim the title of the world's most potent airliner. Positioning its 4 Rolls-Royce Conway 301 turbofan engines at the rear substantially mitigated cabin noise. Additionally, the aircraft boasted a reinforced frame with over half composed of solid steel and alloys, along with fully redundant systems to bolster safety and reliability. Despite fervent marketing efforts to showcase the VC-10's prowess, especially amid increasing American competition, Vickers faced precarious financial circumstances due to tepid demand for the jetliner. The British government intervened, pressuring BOAC to expand its orders to enable Vickers to break even, if not turn a profit. BOAC harboured reservations regarding the VC-10's fuel efficiency, especially upon discovering that the Boeing 707 boasted a lower cost of £4.10 per passenger mile compared to the VC-10's £4.24. This revelation, which found its way into the media, eroded customer confidence in Vickers. Ultimately, BOAC placed orders for 12 standard VC-10s and 35 Super VC-10s, although it scaled back its standard order to 7 by 1964 as airline expansion stagnated. The British government bought the excess VC-10s and used them as military transports for many years. The Super VC-10 introduced enhancements such as an additional fuel tank in the fuselage and adjustments to engine positioning, effectively addressing issues with tailplane buffeting and fatigue related to thrust reverser operation. Despite the political complexities surrounding its development, the VC-10 swiftly garnered popularity within BOAC's fleet, acclaimed by both passengers and crew for its reduced noise levels and heightened interior comfort. Derived from the Vickers Viscount, the Vickers Vanguard represented a significant evolution. Its redesigned fuselage boasted a double bubble cross-section, maximizing internal space and augmenting cargo capacity. Powered by new Rolls-Royce Tyne engines, the Vanguard attained cruising altitudes of 30,000 feet, establishing itself as one of the swiftest turboprops ever constructed. Notably, the 4 engines demonstrated exceptional reliability and efficiency, facilitating a range of nearly 3,000 kilometers. Unlike earlier aircraft, the Vanguard's wings contained integrally machined skins of light alloy to provide span-wise stiffening at low cost, and 3 shear webs rather than the single spar in the Viscount wing. Operating the airplane demanded considerable physical strength, as all flight controls were manually operated without power assistance. Additionally, adjusting thrust resulted in significant yaw, given that all 4 sizable propellers rotated in unison. Regrettably, by the time Vanguards entered the market, turbojets had surged in popularity, leading to limited demand for the colossal turboprop. Trans-Canada Airlines and DEA stood as the sole customers, with only 43 Vanguards ever manufactured. Nevertheless, BEA Vanguards proved invaluable on bustling European and UK trunk routes, boasting 139 passenger seats. Despite initial challenges, the Vanguard proved to be remarkably profitable. On shorter distances, it even matched the travel times of jets servicing the same routes. With increased passenger capacity, ticket prices plummeted, prompting a shift in travel habits as people began considering medium to long-distance flights over driving. Airline travel started to become accepted as a fact of everyday life. Despite the challenges faced by the British aviation industry, the government seized the opportunity to host the King of Nepal on a highly publicised tour of the Vickers Armstrong factory during his visit to England in 1960. Welcomed by Brigadier Generals Charles Dunphy and Sir George Edwards, the King was escorted to the Vanguard assembly area and presented with completed aircraft on the tarmac. While media attention primarily focused on the civilian airliners, the primary objective of the visit was to showcase Vickers Armstrong's array of military hardware, a cornerstone of Britain's vital export industry. The British Aircraft Corporation 111 emerged as the second short-haul jetliner to enter service, undergoing testing in the early 1960s. Tragically, the prototype met with disaster on October 22, 1963, resulting in the loss of all lives on board. Subsequent investigation revealed the occurrence of a deep stall attributed to diminished airflow to the tailplane due to the obstructive effect of the aft-mounted engine nacelles at high angles of attack, impeding the aircraft's ability to recover normal flight. Stick shakers and stick pushers were added to the control system, and the wing's leading edge was redesigned to smooth airflow into the engines and over the tailplane. Another test variant experienced a rough landing at the Wesley Test Centre, resulting in severe damage to its landing gear and undercarriage. Despite this setback, the airliner proceeded into production and enjoyed a successful career as a commercial transport for many years. The pioneering jet airliner to enter production in continental Europe was the Sud Aviation Caravelle from France. This graceful twin-engine turbojet made its maiden flight in 1955 and commenced service 4 years later on the Paris-Rome-Istanbul route. With a seating capacity of up to 128 passengers in a single-class configuration and manned by a flight crew consisting of 2 pilots and 1 engineer, the Caravelle epitomized efficiency and elegance in air travel. Although initially trailing in jet airliner development, Lockheed's propeller-driven airliner, the Constellation, emerged as one of the most beloved post-war passenger aircraft.
Now watch this. Feather 1.
Feather 1.
Feather 2.
Feather 2.
Look at that, on 2 engines. Purring along just like a kitten. You haven't seen anything yet. Feather 3.
Feather 3.
Boy, oh boy, look at that. On one engine. Going along just as steady as you like. Only a Constellation can do this. Why do we have all that tremendous reserve of power? Because, my friends, power means safety. That's why this Super Constellation is the most dependable airliner in the world today. Okay, Hugh, bring in one.
Unfeathering 1.
As the first widely used pressurized airliner, the Connie graced the fleets of airlines worldwide.
Gear down.
Gears coming down.
Eastern 601, cleared to land. The captain will reverse the pitch of the propellers and push the air forward and just stop the plane. There. You see, that acts as a powerful brake. So next time when you're riding in an airliner and you hear the engines roar soon after you're on the ground, remember that's what he's doing, reversing the props to stop the airplane.
Maintaining its relevance throughout the 1940s and 1950s, until the emergence of jet transport ultimately led to its retirement. Jets revolutionized mass transportation, ushering in a new era of air travel accessibility and efficiency. America envisaged a golden future for its new Boeing 707 airliner.
1000's destination, London. Luggage was prepared for loading, and all other routine pre-flight activities were taking place. 1000 seemed to be just another flight to London, in all respects except that its passenger list was twice as large as on ordinary trips. Flight 1000 was airborne, but no plane was used. This was the first of so-called airline paper flights, a complete simulation of an actual flight that's been repeated more than 2,000 times since. The reason? To prepare for the revolution in transportation that is now here, the advent of commercial flying by jet clipper. In those early days, weather information for Flight 1000 and all the other paper jet flights was gathered as carefully as if real jets were to cross the Atlantic, gaining invaluable advance information about jet travel. For example, it is now known that at the altitudes at which jets cruise, generally 30 to 40,000 feet, flying will be above the weather. After years of paper flights like number 1000 and many hundreds of real flights with prototypes, the jet age is now here. The jet age begins before takeoff, at the airline's new terminal, now under construction at Idlewild Airport, New York. Jets are parked around it, as in this model. Passengers will board by walking along a covered ramp directly to the cabin level. Ground transportation delivers travelers directly to check-in counters. The circular design of the terminal, along with its unique cantilever roof, will assure speed of service and convenience for passengers. This is it.
the first American commercial jet capable of economical transatlantic service, the Boeing 707 Jet Clipper. First to go aboard cargo and mail. Cargo shipments will be able to reach Europe in just 6.5 hours. A letter posted in London or Paris after the close of business may arrive in New York the same night and be waiting for the addressee at his breakfast table or office the next morning. Speed is a byword for every part of jet operations, since with some arrangements of seats, more than 150 passengers can be accommodated, there is an entrance at the back and the front, while plane servicing facilities are on the far side. One indication of the staggering impact of jet travel, every one of the airline's dozens of jet planes can carry as many people in a year's time as the biggest ocean liner.
The Boeing 707 boasted 35-degree swept-back wings and was powered by 4 Pratt & Whitney JT3C turbojets, representing the pinnacle of aviation technology. However, before the 707 could enter into service, there were still challenges to overcome.
More jet news from Seattle, USA, where the new Boeing jet airliner, America's challenge to the Comet, is all set for her first taxiing tests. All seems well with the 95-ton giant, then a sudden collapse as the port landing gear buckles. Fire trucks race to the scene as the pilot and crew scramble out of the damaged aircraft. The jetliner cost nearly £6 million to build. Experts fear that its first test flight will be delayed many weeks.
As the design underwent refinement, excitement and anticipation mounted.
Takeoff, without any need for engine warm-up, with outside noise now reduced to no more than that of propeller-driven planes, capable of traveling at 575 miles per hour or more, much higher and faster than you've ever flown before. The first passenger jet clipper to fly the Atlantic. Because of its greater size and speed, it will do the job of several of the biggest propeller-driven planes. Welcome aboard. Welcome aboard the spacious cabin, attractively decorated, air-conditioned but draft-free. Newly designed individual overhead light units are an innovation. Roominess extends even to the powder rooms, which look like those in a private home. And a new sensation, complete absence of vibration. Near sonic speed, but inside one of the most stunning discoveries. There is no feeling of movement at all, no vibration, hardly any sound. A new concept in air transportation. The travail has been taken out of travel.
Ladies and gentlemen, this is your captain speaking. We're now at cruising altitude, 35,000 feet. Our flying speed is 575 miles per hour. In addition, we're benefiting from a substantial tailwind by courtesy of the jet stream. Hence, our ground speed is now approximately 658 miles per hour. Indications are that our arrival at London Airport may be ahead of schedule. I'll be speaking with you again from time to time. Thank you.
Despite being edged out by the unexpected transatlantic crossing of the Comet 4, the Boeing 707-120 made its debut on October 26, 1958, just 22 days later, with an impressive flight from New York to Paris, including a fuel stop in Newfoundland. The 707 quickly overshadowed British jetliners in popularity, but a series of unfortunate incidents less than a year later shook public confidence in the airliner. The jet encountered a string of mishaps, including emergency landings prompted by failures in the hydraulic system. One crippled aircraft was captured on film landing at Idlewild Airport, trailing a dramatic plume of flames as it came to a stop. Despite the precautionary deployment of emergency slides, most passengers disembarked via the stairs. The day before, a Qantas 707 had suffered an engine failure 150 miles out to sea. Fortunately, the aircraft with 82 people on board was able to make it safely to land on the other 3 engines. The first major accident involving the Boeing 707 occurred on August 17, 1959, when a test flight ended tragically with a crash shortly after takeoff on Long Island, New York, claiming the lives of all 5 crew members. Rescue teams worked diligently to salvage as much wreckage as possible to aid in the investigation, which was spearheaded by the U.S. Civil Aeronautics Board. Investigators determined that the pilots were conducting simulations of engine failure on 2 engines on one side when the accident occurred. In response to the findings, the Federal Aviation Authority implemented a new regulation stipulating that exercises involving 2 engine failures could not be conducted below 5,000 feet. Amid concerns that the flagship airliner might suffer a fate similar to the ill-fated Comet, some policymakers advocated for grounding the 707. However, Boeing staunchly defended its jetliner.
Saturday's Long Island crash, when the crew of 5 were killed, followed more than a dozen incidents ranging from minor electrical faults to landing gear trouble and wheels dropping off. These facts were put by our reporter Douglas Brown to a Boeing Airplane Company executive, Mr. Bromwich.
Well, it is true that we've had a certain number of difficulties with the 707, but these troubles have not fallen into any pattern. That is, there haven't been any consistent troubles with the 707. We have had some hydraulic system troubles, but as far as the major incidents are concerned, they've all been a little bit different one from the other. So we can't say that we have a family of troubles here that we can really work on.
Awful lot of them, though, hasn't there?
Well, I suppose so, but every airplane that's introduced into service has difficulties at first. We probably have had a little bit more publicity than the other people have had because, after all, it's a new device, and people are interested in what happens to transportation devices. Witness the headlines that occurred when the Queen Mary ran into, or was it a freighter ran into the Queen Mary?
Influential people in the United States themselves have called for the aircraft to be grounded.
Well, of course, we had a member of the House of Representatives call for it to be grounded, but there are 486 members of the House of Representatives, and I'm sure that out of these 486 people, you could find at least one who likes to get his name in the paper.
Is there anything in the criticism that the 707s should have been tested more on the ground before they were allowed into the air?
Well, from the Boeing airplane point of view, I don't know what we could have done. We've spent an awful lot of money on the airplane. We've actually started designing the airplane in 1952 and first flew the airplane in 1954. We have spent a great deal of money on it, and as we look back on the thing, I don't know that anybody in the company could say that there are things that we shouldn't have done in the way of testing.
Despite the setbacks, Boeing maintained a dominant position in the aviation industry. However, Douglas Aircraft was swiftly gaining ground with its own 4-engine jetliner, the DC-8. With Boeing beginning deliveries to Pan American Airways in October 1958, Douglas accelerated its testing schedule, sending 10 aircraft for certification by the Federal Aviation Administration by August 1959. A number of remedial works were carried out, including replacing air brakes with engine thrust reversers and adding leading-edge slots to improve low-speed lift. In September 1959, the first DC-8 entered into commercial service with Delta Airlines and United. 2 years later, a DC-8 achieved the milestone of becoming the first civilian jet to achieve supersonic flight. Although the Boeing 707 was often considered the superior aircraft, the DC-8 demonstrated remarkable staying power. By 2002, of the 1,032 707s manufactured for non-military use, only 80 remained in active service. In contrast, of the 556 DC-8s produced, approximately 200 were still in commercial operation, with some serving as cargo planes. Nevertheless, the era of jet aviation was undeniably dominated by Boeing. Throughout the 1960s, the aerospace giant solidified its hold on the American market and expanded its influence globally.
After 84 minutes, the first flight ends, and congratulations go to the pilot for blazing a new trail in the sky.
The Lockheed Constellation, affectionately known by many as the Connie. One of the most elegant and aesthetically pleasing aircraft to ever take flight. But being a thing of beauty was not its only grace. Lockheed took a giant technological leap to give birth to the Constellation. It was a leap so far ahead as to give Connie a lease on life, extending long after many of her prop-powered rivals rusted into obsolescence in the era of the turbojet. Her perfection of form and function can be traced to the dawn of commercial aviation. She was the end product of years of battles between the airlines for dominance of the skies. This struggle for economic survival would see the airlines and airliner evolve into their ultimate modern forms and unite the globe through air travel. In the late 20s, the fledgling American airline industry was still using aircraft like this Ford trimotor with its fixed landing gear. Technically primitive aircraft, by today's standards, and capable of short hops between cities only. Intercontinental airlines still relied on railways to ferry passengers for part of their trips. In this early age of aviation, the rules governing airlines and safety were still being written, sometimes lagging behind quickly evolving aerospace technology. Although not as dangerous as a ride with a daredevil barnstormer, a commercial flight could still be a risky proposition. A fatal crash in 1931 opened the world's eyes to the perils of flight. That year, TWA Flight 599 came down in the Kansas prairie, killing famous football personality Knute Rockne and 7 others. Rockne was a passenger on another type of trimotor, the Fokker F7. Unlike the all-metal Ford trimotor, it had wooden wing components, and moisture may have weakened the glue holding them together, causing them to fail during flight. Rockne was beloved by the American public, and the Rockne crash, as it became known, led to major changes in commercial aviation standards. Some improvement in speed, safety, and comfort were seen early in 1933, when the Curtiss Company launched the Condor airliner. Though it was a biplane and had a traditional frame and fabric construction, it had a tubular metal wing spar. The Rockne crash caused wooden aircraft to become the pariah of the airlines. As commercial flights became longer, passenger comfort became a greater priority. The Condor was the first aircraft to offer sleeping berths for overnight flights. Like today's airliners, it also had its own galley, providing fresh hot food and beverages for its passengers. Only about 40 Condors left the production line, and it did advance the passenger airliner, but an innovative new aircraft from Boeing would set the next benchmark for civil aviation. Boeing's Model 247 was breathtaking in comparison to anything else available, and all the airlines wanted it. It was faster than the fastest American fighter of the day, and it could beat the Condor across the USA by 8 hours. It was also a safer, more comfortable plane for its 10 passengers. It was all metal in construction and could fly on a single engine if one should fail. As well, the cabin was soundproofed and air-conditioned. The 247 was a solid design that could have dominated, but corporate greed got in the way. Boeing sold 60 of its aircraft to its affiliate airline, Boeing Air Transport, part of UATC, the predecessor to United Airlines. TWA and others were clamoring to get their own 247s, but their orders were to be postponed until the entire United order was fulfilled. Locked out, TWA and other airlines turned to aircraft manufacturers Douglas and Lockheed to build their new fleets. From Lockheed, the company that would one day create the Constellation, came the Model 10 Electra. Like the 247, it could initially carry 10 passengers, was of all-metal construction, and had twin engines. By this time, single-engine aircraft had been banned for all passenger and night flights. Kelly Johnson, then a student assistant at the University of Michigan, did much of the wind tunnel work on the Electra. He was a champion of the Electra's twin tails, which would later become a hallmark of Lockheed aircraft. Johnson would become a leading light at Lockheed and contribute to the Constellation's design. The Electra was a decent alternative to the 247, but Douglas had an aircraft in the works that would eclipse both of them and come to dominate civil air travel. TWA had turned to Douglas when their 247 orders had been rejected. The airline was looking for a new tri-motor, but Douglas answered with a groundbreaking line of aircraft. The DCs, short for Douglas Commercials. These twin-engine, all-metal aircraft had the range and seating capacity to knock all competitors out of the sky. From the prototype DC-1 to the DC-2 to the DC-3, seating went up from 12 to 14 to 21. In terms of performance, the DC-3 could fly eastward across the USA in 15 hours, with just 3 refueling stops. Hundreds of DC-3s were constructed, compared to just 75 Boeing 247s. With so many of their planes in the air, Douglas had a major role in popularizing air travel. But for all the improvements that had taken place, aircraft manufacturers still had a long way to go in terms of performance and comfort achieved by a pressurized aircraft like the Constellation. Pressurizing an airliner would allow passengers and pilots to fly comfortably at higher altitudes and in the jet stream, cutting flight time and fuel costs. But it wasn't until 1937 that the first U.S. experiments got underway. It was in that year that the U.S. Army commissioned Lockheed to modify a standard Model 10 Electra with a new pressurized fuselage. The XC-35 was a watershed in aircraft design. It was an experimental aircraft constructed to prove that it was feasible to fly above the storms. Windows were smaller than found on the Electra for fears of a blowout. All these modifications allowed the XC-35 to fly at 30,000 feet and take advantage of the jet stream. The age of pressurized aircraft had arrived. With this new technology in hand, airlines were looking ahead to a time when they could offer non-stop, coast-to-coast flights and intercontinental flights, carrying enough passengers to make such trips economically feasible. To do so, they would need an all-metal, 4-engine plane, large enough to carry 40-plus passengers over a distance of 2,000 miles. In 1935, before the first DC-3 had risen into the air, United Airlines had expressed serious interest in an aircraft with these specifications and went to Douglas for help. 5 other airlines joined United's venture, including TWA, each contributing $100,000 apiece to the project. It was a small amount of money compared to the millions their investment might return. Douglas answered their challenging specifications with the DC-4E. It was a 4-engine aircraft that could carry 42 passengers, twice as many as the DC-3, a distance of over 2,000 miles. Like the later Constellation, it had a tricycle landing gear and a triple tail. It also had air conditioning, power-boosted controls, and production versions were to be pressurized. Such an aircraft could change the landscape of civil aviation, but as development costs increased, Pan Am and TWA lost interest. The prototype DC-4E did fly in June of 1938, and testing was successful, but it was too expensive, and performance was below expectations. The project was canceled. In the end, the prototype was sold to Japanese Imperial Airways, who secretly reverse-engineered the aircraft to create the Nakajima G5N bomber. Japan wasn't the only nation gearing up for war. In the late 1930s, with communism and fascism at odds with each other and global tensions rising, war was a possibility, and aircraft manufacturers were preparing for the battles ahead while still keeping an eye on the civil market. Boeing attempted to re-engineer their B-17 bomber to create a new airliner, the 307. Boeing fused B-17 wings, undercarriage, and tail section onto a new, wider pressurized cabin to create the 307. It could fly its passengers in comfort high above any bad weather. However, because of its B-17 heritage, the 307 still had to utilize a tailwheel, making for less safe takeoffs and landings than an aircraft with tricycle landing gear like the DC-4E. Altogether, only 10 307s were sold. At this time, Lockheed was in development of their own four-engine passenger plane, the Model 044 Excalibur, which at first glance appeared to be a larger version of the Model 10 Electra. Howard Hughes would call for radical changes to this design that would reshape the Electra into the ultimate prop airliner. When Hughes gained control of TWA in 1939, he wanted an airliner which incorporated all the latest technology available. But no such aircraft were in the air. On top of his technical requirements, he was looking for great style and extra performance. Funding from the lucrative Hughes Tool Company was the only way Howard Hughes could pay for such an ambitious project. With cash in hand, there was little doubt that he would get his way. The final rendition of Lockheed's super airliner model was so different from the 044 Excalibur first proposed that it was also given a new name, the L049 Constellation. The plans for this streamlined, elegant aircraft fit Hughes's bill for style and performance. Lockheed designers, including Kelly Johnson, borrowed elements from other aircraft to create the Constellation. It was pressurized like the XC-35 and able to fly its crew and passengers at a ceiling of 24,000 feet. As well, its wings were adapted from those of Lockheed's P-38 Lightning, and its triple tail and tricycle landing gear were reminiscent of those of the Douglas DC-4E. Even with such a stellar design in the works, the more primitive Excalibur was not cancelled. It has been suggested that the more modest Excalibur concept had actually been kept in development to distract interest away from the greatly advanced Constellation. This was part of a ploy to keep TWA's monopoly of the Connie. Since Boeing had executed a similar maneuver to keep their 247 out of TWA's hands, there is little doubt that Howard Hughes was capable of such tactics. Just as the contracts were signed and planning for the Constellation prototype got underway, the world braced itself for war. Hap Arnold, head of the Army Air Force, voiced serious concerns over the rise of Nazi Germany. He stressed the need for a backup for the already planned B-29, a long-range bomber capable of striking the U.S.'s foes wherever they might be. Lockheed was now obliged to develop a bomber version of the Constellation, the XB-30, to play understudy to the B-29. The plan for the Connie's conversion was simple and lauded by the Air Force. Graft a Constellation's wings and tail section onto a new fuselage, housing bombs rather than passengers. In the end, however, there was no need for a backup bomber. Boeing delivered the B-29 Superfortress, and the XB-30 was cancelled. The end of the XB-30 was not the end of the Constellation's military career. In December 1941, when war came to America, the military took control of the entire L-049 project. The Constellation became the C-69, a high-speed transport aircraft for troop movement. In January of 1943, 4 years after Hughes proposed its groundbreaking design, the C-69 finally took to the skies. It was still several months before all engine problems were sorted out, and the aircraft was handed over to the Army Air Force. The second C-69 had a much more glamorous debut. Though it was still a military machine, it was allowed to be presented in striking TWA livery. Even more surprising was that Howard Hughes was allowed to pilot it trans-America on a record-breaking flight, a record at the time equal to any belonging to a modern fighter. A great deal of successful publicity was gained for all concerned, and the Connie was certainly winning hearts, but not that many orders. In fact, the total number of wartime deliveries was just 22. The Army was in desperate need of transport aircraft. They just weren't buying them from Lockheed. After the failure of the too advanced Douglas DC-4E, Douglas went straight back to the drawing board and produced a far less ambitious aircraft, originally known as the DC-4, with no E. It was quickly militarized into the C-54 Skymaster. C-54s had no pressurized cabin, and although they did incorporate a tricycle landing gear like the earlier DC-4E, overall they had a much simpler layout. This made for quicker production, easier service, and greater reliability, exactly what America needed in a wartime situation. With all of these advantages, the C-54s drained away the Constellation's military orders. Between 1942 and into the early post-war years, over 1,200 C-54s and DC-4s were produced. But the aviation marketplace was quickly changing. As World War II ended, aircraft manufacturers had to reverse course and focus their energies on the civilian market. A number of Skymasters found their way into post-war civil use, with some being retrofitted with pressurized cabins. It was in this early post-war period that the Constellation sales took off. Her extra size, more powerful engines, and pressurized cabin all became prerequisite features for a new generation of airliners. Luxury and comfort were now being offered, and the public was willing to pay for Constellation quality. However, Lockheed's competitors weren't ready to concede defeat. Boeing was looking to capitalize on the success and technology of the B-29. They started by creating a new tanker, the C-97. Like the proposed Lockheed XB-30, they took the wings and tail section of an existing aircraft, the B-29, and grafted them onto a new, larger double-decker fuselage. The C-97s were originally built in large numbers as Air Force tankers and freighters. However, it didn't take Boeing too long to see the lucrative potential of the airliner market. The Boeing Model 377, or Stratocruiser, was an airliner version of the C-97. With its second deck providing much greater seating capacity and its extra range, the 377 looked like it would give the early Constellations some serious competition in the luxury airliner market. However, only 56 aircraft were produced. They certainly delivered all that was promised in the luxury department, but they proved uneconomical to run. Also, 2 serious accidents resulting from their complicated engine and propeller arrangement became a source of serious concern. Although the Stratocruiser had only a limited impact on the civilian airliner market, Lockheed and the Connie still had one more player to contend with. When the war was still raging, the Army had contracted with Douglas to make an advanced Skymaster prototype, longer and with more powerful engines, and at last with a pressurized fuselage. At war's end, Douglas would take the prototype and research paid for by the Army and use them to create their new civilian offering, the DC-6. Its overall look was somewhat more sedate than the elegant Connie, but it would still prove a very worthy adversary. Throughout the decade that followed, many modified DC-4s and hundreds of brand new DC-6s and later DC-7s fought it out with numerous generations of ever-improving Constellations. As Lockheed and Douglas tried to capture the imagination and contracts of airlines around the world, they increased the seating capacity, range, and storage of the respective aircraft. With airliners available to take passengers around the globe, the long-range airline business grew in all directions. Luxury travel was augmented by tourist and economy seating. The term coach became common at travel agents and airport check-ins. Lower fares meant higher volume and access to an entirely new market of average middle-class citizens. Douglas continued to provide transports as it had in World War II, while Lockheed created a new early warning radar aircraft, the Warning Star. Over 230 of these advanced electronic surveillance aircraft provided critical support for the Air Force and Navy, especially during the Vietnam conflict. Business was booming for Lockheed and Douglas in both the military and civilian markets, but soon their streak of good fortune would come to an abrupt end. Rival Boeing returned with an unbeatable new aircraft design, which would rattle the foundations of the airliner world, the jet-powered 707. Boeing's president, Bill Allen, had bet the company on this aircraft. The 707's swept wings, potted jet engines, and other advanced technology made the Constellation and DC-6s and 7s seem like antiques from a bygone era. In a brilliant business move, Allen created a militarized version of the 707, the KC-135 tanker, in parallel with the 707, allowing him to save money on research and development and tap into the military and civilian markets simultaneously. In 1957, the same year the 707 took flight, Lockheed unveiled its most advanced constellation, the Starliner. It was packed with new advanced features. The Starliner's turbo compound engines allowed it to fly non-stop from California to Europe. But the aircraft was costly compared to similar offerings from Douglas. As well, airlines wanted to add jets to their inventories, not only for performance, but for prestige. There was more bad news for Lockheed on the military front. Although the Warning Star would continue to play an important role as an early warning aircraft into the Vietnam War, it was ultimately superseded by the Boeing E-3 Sentry, a radar-equipped version of the 707. Douglas and Lockheed both attempted to wrench the jetliner monopoly from Boeing, but only Douglas was able to crack the market successfully with their DC-8. DC-8s and 707s battled for air supremacy, just as the DC-6s and 7s had competed with the Constellations in the years leading up to the jetliners. In the mid-70s, Lockheed did attempt a comeback in the airliner market with their jet-powered TriStar. 250 aircraft were sold, but it was far below sales targets. Lockheed exited the civilian market once and for all and instead concentrated on military aircraft. Constellations, once the most advanced airliners in the world, were gradually phased out. They were relegated to backup roles, shorter routes, and ultimately served as freighters. Connie, the Queen of the Skies, was a victim of old age and progress and had to abdicate her throne to the jetliner. She aged gracefully, serving smaller airlines up until the 1990s. Civil aviation went through several revolutions since the early trimotors hopped across the U.S. In this time, airlines rose and fell, and aircraft manufacturers pushed technology forward as they battled for their share of the civilian market. Today's network of airlines and aircraft unifying the globe are the end result.
The United States, of course, has many well-known international symbols, the White House, Statue of Liberty, Mount Rushmore, the flag, but really only the last of those, the flag, is mobile, can actually show the flag, as they say, around the world. Would you think it's fair to say that Air Force One also represents a mobile symbol of the United States? Is that fair?
Yeah, well, I know you've been on Air Force One, and I'll tell you, when you taxi up in our country or in some other country, there's a great emotion about it. And it's, I loved, when I go up and shake hands, you know, at the rope line with some kid, say, was that exciting to see this? Oh, and you can really tell that they were moved, and the teachers bring the kids to see it. And so it has a symbolism that projects. It is a symbol. It is a mobile symbol of the presidency and thus the country.
Even now, many people tend to overlook a plane that has quietly revolutionized the concept of international travel, the Boeing 747. Individuals like the late Juan Trippe, the former president of Pan American Airlines, foresaw its potential right from the beginning.
Juan Trippe came to Seattle to sign the contract. It happened to coincide with the 50th anniversary of the Boeing company, and he was the guest speaker at a large banquet downtown. And so he gave this speech on the 747. And he was a very idealistic man anyway. He'd started more or less international travel by, spawning Pan Am from the days when there were prop airplanes flying and so forth. And he said, I think that the 747 is a great weapon for peace. And it's really competing with the intercontinental missiles for man's destiny, which sort of surprised us all. And he thought it was going to win. And he explained that when you got millions of tourists flying back and forth between countries and they were exchanging their goods and produce and products and so forth, that you'd learn to like each other before and do business with each other before you blow them up, I suppose. And turns out that he's pretty close to right, because 20 years later, we're bringing out a new airplane, the 747-400 version. And that year, Reagan and Gorbachev have decided to scrap missiles. And so, and we're doing it's a trillion revenue passenger miles to be flown in 1989. So Juan Trippe was really a prophet.
On August 16th, 1989, in Sydney, Australia, a new Boeing 747-400, the latest iteration of the 747 series, landed at Sydney International Airport. Covering 18,001 kilometers from London in an impressive 20-hour, 9 minute, and 5 seconds, it marked the longest non-stop airline flight in history. This achievement became a significant milestone in the world of travel during the 747's 21st year. However, the remarkable story of the 747 begins far from Sydney, Australia, both in space and time. On July 16, 1916, in Seattle, Washington, William Edward Boeing established the Pacific Aero Products Company. As the USA entered the war against Germany in mid-1917, Bill Boeing secured an order for 50 of his Model C trainers. By the end of the year, Pacific Aero Products transformed into the Boeing Airplane Company. In March 1919, Bill Boeing and his pilot Eddie Hubbard pioneered the first international mail flight covering the route from Seattle to Vancouver. By 1928, the Boeing 80A represented the pinnacle of travel comfort, introducing the first flight nurse or air hostesses. Improvements in the metal fabrication techniques ushered in a series of metal-skinned, low-wing monoplanes, exemplified by the XP-9 bombers. By 1934, when Roscoe Turner completed a journey from London to Melbourne, Australia, aboard a Boeing 247, a genuine revolution in passenger air transport had unfolded. In 1933, the 247 significantly reduced the U.S. transcontinental flight time from 27 to 19.5 hours. Fitted with twin Pratt & Whitney Wasp engines, it outpaced other airliners of the period by 50 to 70 miles an hour. Despite its groundbreaking design, the success of the 247 was short-lived. When TWA sought a competitor, the birth of the DC series at Douglas rendered the 247 nearly obsolete, especially with the introduction of the DC-2 and DC-3. Undeterred, Boeing shifted its focus to size, unveiling the 4-engine XB-15. It was the first really big plane to use state-of-the-art technology in streamlining and high-performance power plants. Only one XB-15 was built, but Boeing had established itself as a manufacturer of big aircraft. When Juan Trippe of Pan American Airlines approached Boeing with the idea of constructing a large flying boat for intercontinental passenger routes, the XP-15's engines and wing design were repurposed to fit the new hull, giving rise to the Model 314 Boeing Clipper. The Clipper boasted impressive dimensions, with a gross weight of 82,500 pounds and a payload capacity exceeding 15 tons, encompassing fuel, passengers, and cargo. Priced at $700,000 each, the construction of each clipper demanded 350,000 man-hours, representing a significant stride toward Juan Tripp's vision of an affordable international travel system. The clipper facilitated regular scheduled transatlantic services with its extensive range and the ability to accommodate 2 shifts of flight crew. Concurrently, Boeing pursued a different trajectory, aiming upward. Building on the concept of 4 engines and a more compact fuselage than the XB-15 for enhanced performance, Boeing had crafted Project 299, the prototype of the Flying Fortress B-17. This innovation culminated the 4-engine Stratoliner, characterized by a cigar-shaped pressurized fuselage. Equipped with a supercharger to supply oxygen for high-altitude engine performance, the Stratoliner also delivered pressurized air to the cabin. It wasn't the first 4-engine airliner, but it was the first pressurized airliner to enter service. One Trip from Pan American ordered 4 Stratoliners and TWA ordered 5. The inaugural flight of the first Stratoliner took place on December 31, 1938, generating considerable excitement due to its capacity to reach 26,000 feet and accommodate 33 passengers. However, despite its promising prospects, setbacks emerged. A significant crash involving Stratoliner No. 1 prompted the addition of a dorsal fin to enhance stability. The outbreak of World War II interrupted the trajectory of international travel development. Nonetheless, advancements in supercharger pressurization and later turbo superchargers contributed significantly to Boeing's line of large bombers. The production of 12,000 B-17s played a pivotal role in the Allied war effort, not only in bomb deployment but also in air combat, surpassing the combined enemy plane victories of all other American warplanes. The subsequent introduction of the B-29 Superfortress, featuring a pressurized fuselage, marked the pinnacle of World War II bombers. Its historic impact culminated with the deployment of the bomb that brought an end to the war. Post-war, its transport variant, the C-97, evolved into the Stratocruiser, representing Boeing's ultimate achievement in large piston-engine international airliners. In 1945, Boeing's new president, William Allen, recognized the imperative for the company to re-enter the civil aircraft production. He took a bold gamble by announcing the construction of 50 Stratocruisers at $1 million each. The Stratocruiser epitomized luxury and international travel during an era predating the introduction of economy and tourist fares. Its standout features included a spiral staircase leading to the lower deck lounge, providing passengers with the opportunity to stretch their legs and enjoy a change of scenery. Additionally, the ladies' lounge offered a convenient facility for maintaining in-flight appearances. The Stratocruiser's major competitors at the time were from Lockheed and Douglas. They were like this Constellation, essentially pre-war designs. There were also other planes like the British Hermes, flying the international routes. Post-war international air travel did not experience the anticipated boom, leaving the luxury of crossing continents at any time of the day or night accessible only to a privileged minority. In May 1952, the British de Havilland Comet initiated a service from London to Johannesburg, but its introduction to the transatlantic run faced challenges. The trajectory of jet international travel received a boost with the necessity for a new in-flight tanker. The Boeing KC-97, suitable for refueling piston-driven planes, proved too slow for the emerging generation of long-range jet bombers. The B-47, with 6 General Electric J-35 turbojets, took flight in 1947, setting the stage for the next generation. The B-52 Stratofortress, designed to meet the demands of a global defensive weapon with extensive flying ranges. An efficient in-flight refueling system became crucial, leading to Boeing's bold move. The Dash 80 was a novel design with a low-wing and swept-wing monoplane, equipped with 4 Pratt & Whitney J3 engines, initially served as the KC-135 tanker. However, it diverged from its military destiny, evolving into the Boeing 707, the United States' inaugural international jet airliner. The introduction of DC-8s from Douglas on transatlantic routes alongside the 707 marked a turning point. Passengers' numbers surged by 12% annually, prompting Douglas to unveil a stretched version of the DC-8 to meet growing demand. While the 707 faced limitations in stretchability, fate intervened with the U.S. Air Force's competition for a large transport airplane, the C-5A. Boeing, renowned for constructing larger aircraft, enthusiastically entered the contest, dedicating a design team of 500 men to the project in June 1964. The company, drawing on its vast experience in building large planes, was considered to have an advantage over competitors like Lockheed and Douglas. But a year later, in September 1965, the word came out. Boeing, with all its knowledge of big plane construction, had quoted too high of a price, and Lockheed had won the contract to build what became the C-5A Galaxy. However, what initially dealt a blow to Boeing turned out to be a pivotal factor in the future of international jet travel.
When you're competing on something as large as the C-5A, if we had won that contract, it would have absorbed a great deal of our energy, and we probably would not have gone forward with the 747 at that time, and then later. However, the fact that we lost it, and that released a fair amount of energy and resources to do something else, we were anxious to get moving, and it, in a sense, probably accelerated our going into the 747, which it turned out to be a very attractive decision.
The conception of the 747 emerged from extensive consultations with airlines worldwide, and Boeing President William Allen played a crucial role in endorsing the construction despite the absence of firm orders for the plane. Pan American Airlines, with a significant history tied to Boeing's aviation milestones, including the Clipper, Stratoliner, and Stratocruiser, once again played a pivotal role in shaping Boeing's destiny.
Well, Juan Trippe got intrigued in it, and Bill Allen and the two himself, they said, well, what about it? And our designers said, we can design and build it. And he said, if you can build it, I'll buy it. And between the two of them, they struck sort of a deal that they sort of sealed with a handshake. If we would go ahead, I believe the timing this was in February of '66. If we'd agree to build the airplane, that he would buy it, we said, well, we'd have to have orders from at least 3 airlines for 50 aircraft. And if that was the case, we'd go ahead in August 1st of 1966. At that time, we did not have signed contracts, I believe, for the 50, but we were close enough and we were already enraptured with the concept, so we went ahead. I believe that Juan Trippe, in order to ensure that we were serious about it, more or less bet Bill Allen $10 million that he wouldn't go ahead. It wasn't so much a bet. I think it was a if you didn't do it, you'd have to pay the money. But we did go ahead, so we didn't have to pay the $10 million.
On July 25, 1966, the Boeing Company decided to convert this forest into one of the biggest manufacturing complexes in the world. The company decided to erect here the largest factory, volume-wise, ever built, in order to assemble the largest commercial jet airplane in aviation history. The plane was the giant 747, 6 stories high, 231 feet long, with a wingspan wider than a football field. 2 1/3 times larger than a 4-jet 707. At the time, for the first plane, only 31 months go ahead to roll out. But for the factory, time compressed even more. 9 months until fabrication of the first part for the first plane had to begin. Challenges of the factory came first. Challenges posed by the necessity of building that first part on time, of keeping one step ahead of the growing plane.
Clearing timbered hilltops was necessary to make room for the factory, and a massive landscaping effort transformed 630 acres in Everett, approximately 40 miles north of Seattle. Over 250 contractors, subcontractors, and material contractors were involved in the project, with a contractor labor force of 2,800 men representing nearly every construction craft in the area.
Well, as far as a financial risk or a business risk, it was, you'd have to say it was awesome, I guess, because obviously what the money it took to develop, design, and build the prototype airplanes and then build a production rate up was far in excess of the net worth of the entire company. So we were betting the company on the success of the airplane.
The railroad, second steepest in the nation, lifts trains as high as Seattle Space Needle, more than 500 feet, from Puget Sound to factory level in less than 3 miles. The speedy construction of the $2 million railroad was essential. The line would be required initially for hauling material to the construction site, and later for moving parts and equipment to factory assembly lines.
We drew many men and much equipment into that gulch in order to build that railroad. It was tough to get the ballast down and to get the tracks laid. It was thought that we could never do it, but we were able to bring it out on schedule.
The head of facilities for me, a fellow named Bain Lamb, that was building this world's largest building, he used to be a quarterback on the University of Washington Huskies, and I had been a guard at Georgia Tech, and he never liked taking orders from a guard anyway, but he came to me one day and he said, we're not going to get that on time. And I said, the devil, we're not, what do you need? He said, well, I need more people. And I said, you've got them. And then he said, I need more equipment, our earth moving equipment. I said, you've got it. And he said, I need more money. He said, don't bother about it. We'll we'll get it for you. And he said, I need 2 weeks of clear weather. And I said, you've got it, And then, as it turned out, God got even because it rained 67 days in a row.
There were always problems. No sooner had clearing begun than rains swept the site. Equipment wired down.
And we found that this glacier till that is so hard also turned out grease. We couldn't work, obviously, in the mud, so we paved about 100 acres under the buildings. Then we were able to work out of the dirt and out of the mud.
Size and speed of the project demanded rigid controls at every turn. As Director of Facilities, Bain Lamb explains,
every single thing that goes on in the project is scheduled and planned in this room. We can tell at an instant whether or not we are ahead or behind schedule.
Overcoming the challenge of job overlap between construction workers and aircraft builders was one of the major hurdles for the planners.
The contractors we knew were going to be in the area adjacent to our people, overhead in the structures, in the towers, underfloor in the trenches and the ducts. At the same time, Boeing people would be trying to produce the parts that would later go into the airplane.
Simultaneously, Joe Sutter, the chief project engineer for the 747, and his team spent over a year finalizing the plane's design to ensure that a mock-up construction could commence promptly once the building was ready, or if necessary, even before that. As soon as it became feasible, construction crews transitioned inside. While interior walls were being installed, activity continued outside on the roof. Electricians worked indoors, stringing cables, while steel workers outside completed the walls of the mock-up building. The building was scheduled to be occupied in midwinter, specifically in January 1967.
We realized early that we were not going to be able to turn over a completed facility. It would be not heated, would be wide open on one end. The floors would still be curing out. A shell is about all we had to deliver. They were wearing gloves and their mackinaws, their hard hats.
They were very, very motivated. The workforce, there was no need to try to energize them. They were on a very romantic task. They're building the world's largest airplane. And they would, we had people that would drive all the way from Tacoma, which is 70 miles away, to get to Everett to work on the aircraft. They had an enthusiasm that welled up, and finally someone coined the word that they were the Incredibles. And trying to think of who decided, but they got Paul Bunyan insignia and put it on their hard hats. They had to work on hard hats because the building was still under construction, and on their lunch pails, and they had them on their jackets and what have you. And they really did a yeoman's job. Yeah.
It was incredible. And the Incredibles is what they were called.
The railway from Puget Sound to Everett ran up its steep incline right into the factory in order to bring the literally millions of parts of the plane together in the right place at the right time. The factory was virtually a city in of itself. It was the world's largest building in cubic capacity, covering 43 acres under one continuous roof. The facility housed thousands of workers and boasted its own food and medical facilities. Resembling a stage as vast as the 40 football fields, eagerly awaiting the arrival of its principal player, the player whose lines had been meticulously polished and refined over many months by a dedicated team, aimed to ensure that everything would be flawless when the curtain rose on opening night.
The whole job started way back down the line when engineers were still looking at paper airplanes and models, and wind tunnel testing began.
Our people devote literally thousands of hours of their time, and both on paper and in the wind tunnel, to minimize drag, because drag is money. Drag costs weight, drag costs fuel.
During the early development stages, Joe Sutter and his team explored nearly 50 different potential shapes, including a double-decker mid-wing configuration. Wind tunnel testing, costing millions of dollars, rigorously measured and recorded every aerodynamic parameter. To power the 747, Boeing sought an entirely new engine, securing one from Pratt & Whitney, who had been working on a similar but smaller concept for the C-5A competition. The high bypass ratio engine, an evolution of the fan jet known as the JT9D model, delivered 43,500 pounds of thrust, equivalent to 87,000 horsepower. Pratt & Whitney tested the engine using a leased B-52 from the Air Force, modifying it to replace two of the B-52's standard engines with the JT9D. In the flight test program, the B-52 reached altitudes exceeding 45,000 feet, and under extreme conditions, the engine received a clean bill of health. The Praying Mantis, a device designed to simulate the experience of taxiing the 747 from a cockpit positioned 29 feet above the ground, played a crucial role in preliminary testing. Jack Waddell, the 747's chief test pilot, actively participated in this testing, demonstrating remarkable precision by parking it next to a cargo dock with a tolerance of plus or minus 6 inches with practice. It proved to many 747 customers that a huge plane would not be an uncontrollable horror around airports. The prospect of emergency evacuation from an unusual height was also faced in the early 747's development, and pilots were given an opportunity to fly in a simulator that used a remotely controlled TV camera scanning an accurate terrain model. In the simulator, the pilot wielded control over speed, altitude, and attitude, aiming to closely mimic the behavior of the actual plane as predicted by the designers. The full-scale mock-up of the 747 served as an engineering tool, systematically testing every part and system destined for the completed aircraft. This meticulous process was essential to ensure the seamless fit of all 4.5 million pieces in the intricate jigsaw puzzle, sourced from numerous subcontractors spanning various locations inside and outside the U.S. The successful assembly of such a colossal jigsaw puzzle presented substantial planning and logistical challenges for the management team. They had to meticulously orchestrate the accurate placement of components in the 43-acre floor of the Everett factory in Washington State.
As you know, there's literally millions of pieces in the airplane and parts, and they were coming from almost all of the 50 states and 17 foreign countries, and so that you had a tremendous logistics problem to get all of these designs and parts and schedules to mesh to bring together a line that was finally going to end up to being building a 747 every 3 days, roughly. They're on a 7-a-month schedule, and we work, as you know, 22 days a month. So it was a tremendous, problem and complexity. And computers weren't really available in the same dimension they are now. And so we were doing a lot of this with older techniques. And so it was an awesome job to keep track of the parts and make sure everything got designed right and tested and put into the airplane.
Given the project's scale and innovation, new materials and engineering techniques had to be designed and developed. A large machine shop was established in Auburn, south of Seattle, to craft precision tools and massive jigs that couldn't be produced elsewhere. Without such innovations, economically viable manufacturing of the 747 would have been unattainable. Now, the pivotal moment arrived. The assembly of the 747 No. 1 commenced. The nose section arrived from the Boeing plant in Wichita, and the significant pieces of the jigsaw puzzle started to converge. The systems, initially designed in theory months prior, were now undergoing practical tests, and the trials were exceptionally rigorous. During this phase, the tolerances demanded of the engineering process were the most precise ever required in the aircraft industry at the time. The level of tension on the factory floor mounts. These people have committed themselves fully to the project, and now the 747 No. 1 is beginning to emerge as a whole plane from the sum of its millions of parts. The tail, the height of a 6-story building, many times higher than the altitude reached by the Wright brothers on their first flight, is lowered into place. From the tip of the tail to the tip of the nose, it is also longer than the distance flown by the Wright brothers at Kitty Hawk in 1903. Even with the fuselage and wings assembled, the building process is far from complete. A Boeing 747 comprises 135 miles of wire, much of which was to be meticulously fitted by hand. The full project required the use of 75,000 engineering drawings, and strict adherence to assembly instructions was imperative. The 747's hydraulic system is intricately designed, incorporating safety backup systems to compensate for any potential failure. Coordinating the assembly within the allotted time was an immense undertaking.
I can remember it being a all-encompassing job. We spent 365 days a year working on it, and 7 days a week. I think we would have averaged something like 12, 14, 16 hours a day. I mean, the management. Some people said, I don't understand how Boeing can put an airplane out in 4 years. Well, another way is we did it in 8, but we crammed it into 4. It was a compelling job, and everybody that worked on it was sort of swept up into the enthusiasm for doing it.
26 months ago, as we stood amidst the forest up here at Everett, and the decision was made to go forward with the 747 program, the magnitude of the task that we were faced with really looked formidable.
On Monday, September 13th, 1968, Bill Allen witnessed his vision realized.
We have an airplane now, a remarkable one. Let us move forward to see it in service on the airlines.
And now, let's see the airplane.
Those present on the day recall that, initially, the plane didn't appear very large until it drew closer.
26 stewardesses, representing the 26 airlines that have ordered 158 747s, take part in the christening ceremony.
If you haven't got a bomb, raise your hand.
Organizing the christening may have been Malcolm Stamper's most challenging management task.
All right, now we're going to christen her, as you know, on the count of 3. Don't do it yet, but on 1, you're going to pick the bottle up. 2, over our shoulders. 3, all the way down. Okay? Now the cadence, don't break it yet. The cadence is going to be 1, 2, 3. Got it? Okay, wait! All right. They're doing it again. 1, 2, 3. Thanks, everyone. Well done.
The 747, in order to get it ready for the traveling public, we really torture the planes. We build 2 airplanes that we destroy in the process. One of them we call a fatigue test airplane, and we actually put it in a harness and fly it for the equivalent of 30 years, let's say, 60,000 hours. And we make it take off, land, so forth and so on, over and over again. And anything that fails or breaks over time, we fix and then put it into the production line improvements. We also take the airplane and break another airplane and break it up in pieces. We want to know what it takes to break a wing. If you take the wing of a 747, you can deflect it 29 feet at the tip before it breaks. And that's quite a scene to watch it when it finally lets go. I mean, it sounds like an explosion. We break the tail off. We go through a complete destruction of the airplane, finding its real strength. We have all sorts of difficult tests. We'll take the 747 and purposely drag its tail on the runway to make sure that it will take off in that mode if the pilot over-rotated the airplane.
The VMU tests determine the maximum performance of the aircraft at the takeoff configuration. They're performed by placing the tail section of the aircraft in contact with the runway until the airplane lifts off. The speed at which it lifts off is called the minimum unstick speed, or VMU. So the VMU then determines basically the takeoff performance of the aircraft. It also determines the ability of the airplane to tolerate inadvertent abuse. In the case of the 747, it's impossible to abuse the airplane enough so that it doesn't lift off cleanly with very good flying qualities.
We actually do a rejected takeoff test where we lock the brakes and freeze out the anti-skid devices. What happens is the brakes are locked, so the tires actually burn off, and it actually burns the wheels off, and it sits finally, and it catches fire. And you have to sit in the plane for 5 minutes without touching it. The fire trucks are there to see if passengers are there. They have time to get off, and then you're allowed to put out the fire. We paid the pilots a little extra for this.
During these high-speed flutter tests, the airplane was shown to be highly stable, and we reached Mach number speeds of 0.99, which is 99% of the speed of sound, and as high as 685 miles per hour, true airspeed. The 747 has a landing gear that is forgiving, and whereas that rate of sink in another airplane might have felt like a moderately hard landing, the 747 it will feel soft. I think it's a very forgiving airplane on landing. All our airplanes, we have a system on the connected to the brakes that makes it possible for the pilot to apply brake pedal and not worry about skidding the wheels and then blowing some tires. This protective system is on all our airplanes, and on all our airplanes we demonstrate the operation of the airplane during landings and during refused takeoffs, with the system working and with it in various failure conditions. One failure condition is with 2 wheels not connected to the anti-skid system, and then we also check it with all wheels not protected with the anti-skid system and try to show performance of the airplane under these conditions. I thoroughly enjoy flying the airplane. I get a big charge out of it and enjoy it. It has no bad characteristics. It's an honest airplane, and I'm not just saying that from a sales standpoint. I think it's really a good airplane from a piloting and also from a passenger standpoint.
When you get in the airplane, it does seem very high up. Your eye level approximately 27 feet high above the ground. However, you've got very good visibility looking down, so you can see very close to the nose of the airplane. As far as taxiing, it's much easier than, say, a 707 to taxi. After taxiing around for a little bit, or even the landings or the takeoffs, it seems very normal, and the other airplanes seem like they sit too close to the ground.
On December 30th, 1969, following the flight testing period, Federal Aviation Authority officials arrived to pass judgment on the safety of the aircraft. For Boeing executives, a revolution in world transport awaited just a signature away.
You know, the airplane doesn't take very long, but sure it's a big screw, really. I didn't sign the airplane flight manual there. I'm going to sign now the production certificate, the production limitation record. It's going to make certification for the 747. The outcome of this effort is that we find the Boeing 747 as meeting or exceeding the safety standards developed and experienced of the Federal Aviation Administration. As a result of this effort, which included some 1,500 hours of test flying, we are convinced this airplane meets or exceeds the standards for safety evolved in civil aviation history. We therefore recommend the Boeing 747 receive the FAA Type Certificate.
The mostest of everything describes the new giant of commercial aviation, the jetliner 747. Contrasted with great conventional aircraft, the 747 will carry 490 passengers. This is more than double current capacity. Its engines will be twice as powerful as today's airliner. An idea of the size of the engines is emphasized by 2 stewardesses perched on the rim of a jet. Stepping inside the cabin is like entering a small theater. Pilots, stewardesses, and a passenger or 2 provide realistic perspective relative to passageways and rows of seats as they conduct an inspection of this mock interior. The first of these great birds, 25 in all, at a total cost of $525 million, will be delivered by the Boeing Company to Pan American Airways in 1969.
With the 747 now in service, the factory shifted into full production. However, development continued, and within a year, the first new model, the 200B, took to the air. The only apparent external change was the number of windows on the top deck, retaining the basic 747 look and its user-friendly approach to spanning the world's skies. Even before the production lines began to roll, another critical aspect of construction had to be addressed: interior design. The demands of various client airlines for interior design could vary widely. This Air India version from the mid-70s represents one of the more exotic approaches to interior decoration. Before any 747 can be painted, it has to be wheeled over the freeway next to the Everett factory to the paint shop. It's a challenging sight for any passing driver unfamiliar with the area. Masking the fuselage surface is a highly intricate task. For any white-topped version of the plane, more than 70 gallons of paint may be required, and the levels of decoration can vary significantly. In first class, decor can range from simply functional to highly romantic.
I think at last count we may have been building 9 or 10 different models of the 747 because you need them for different things. For instance, the Japanese, who had a regional link stage route for the planes flying between their various provinces, wanted a plane that took off and landed quite frequently. So we went in and changed the landing gear and the flap system to accommodate that. We called it a short range 747 SR. People wanted to fly freight and passengers, and so we made a part of it. We put cargo doors on the side and allowed them to, put large containers into the aircraft. We had people that wanted to fly nothing but freight, so we built freighters where we open the nose of the airplane up, and you can load these 8 by 8 foot containers that would be the size of a huge truck trailer into the aircraft and fly it, and that has become a large business. We had a plane, the Pan Am, wanted to fly longer distance, farther and faster, so we wanted one that would climb higher and have higher speeds, and so we built an SP, Special Performance it was called, and we took a section of it out, so it was a shorter airplane.
So, what's the significance of the number 747 and 747 SR, 747 Combi, and 747 SP?
Well, Boeing has always had sevens in their aircraft numbering. B-17, even the B-52, if you add 5 and 2 together, you get 7, I guess, so that maybe a little bit of mystique. And we had built a 707, which, by the way, had 4 engines, and then built a 727, which had 3 engines, and a 737 that had 2 engines. So you can't make any sense out of this, except 747 was next in line for the number, and so we used it. For 747 has 4 engines.
In 1983, the 747-300 entered into service, introducing an elongated upper deck that allowed airlines to add up to 44 economy seats on that level. The 747 had evolved into the most recognized airplane globally, sparking a complete revolution in international travel.
747, and we talk of it in cents per seat mile, but it's inexpensive enough now to make it open for everyone. Everyone can fly today.
This revolution extended to airport infrastructure, with terminal design requirements expanding to accommodate the growing number of people on the ground. Traditional stairways gave way to air bridges, and baggage carousels became ubiquitous. The plane has had an immense influence on the way people perceive world travel. Since 1968, it has pulled the continents closer together and dramatically increased the number of people who look at world's travel as an everyday and readily affordable fact of life. For about 50 years, the Boeing 747 has carried 4 billion passengers in several space shuttles. During the development of the 747, concerns were raised about its potential to overload airport passengers and baggage facilities and overstress runways and taxiways. While addressing passenger-related challenges took some time, the 747 has proven not to be hard on airport surfaces. It places no more stress on the runways than a 707, and despite accidents in the air, the overall safety record of the plane is excellent.
What started out as our greatest risk turned out to be our greatest reward. The 747 has been a marvelous product for Boeing and for the flying public. It's exceeded our fondest expectations. It's been very effective for us, profitable for us. It's allowed us to have the resources, if you will, to gain the resources to build new airplanes, the 767 and the 757, very advanced designs. It's allowed us to put those kinds of improvements back into the 747, and as you'll notice, it has winglets on it now. And of course, if you could get inside the electronics, you'd find it was all digitized and very modern aircraft. So it's what looked like a really big gamble turned out to be a really big gain.
The 747-400, an improved version of its predecessors, boasts several enhancements. Rolls-Royce, Pratt & Whitney, and General Electric provide more powerful engines. With an 8,000-mile range, the 747-400 enables non-stop flights on legs such as LA-Hong Kong, London-Tokyo, and Singapore-London. Tilted winglets improve fuel burn by approximately 3%, contributing to the improved range. Digital technology has played a crucial role in simplifying controls. Now, a flight crew of 2 can handle the plane with no extra strain, showcasing advancements in efficiency and ease of operation for the 747-400. New generation materials have allowed weight reduction while at the same time increasing strength.
We originally started out, we estimated there might be 600 747s, built in time.
Indeed, the 747 has become a familiar and enduring sight in the skies. Its longevity is a testament to its durability as an aircraft.
The 747 was a great challenge for me, obviously, and as I look back on a career full of interesting and wonderful challenges, it's the number one task I've ever had to do, and it was a thrill to be a part of it. Bill Allen, I pleased with the confidence he had in putting me in charge of it. I worked with a fabulous group of people in designing and building it. It's been a wonderful experience.
The visionary deal struck between Bill Allen and One Trip in 1965 has undoubtedly paid off in a significant and lasting manner, solidifying the 747's place in aviation history.
I think if Bill Allen and One Trip, and I assume they're looking down from heaven at us now, are saying, well, I told you so. I mean, they both were guessing this. I mean, there's what we thought was a great risk for those fellows. They were just smarter than we were. They knew it was going to work.
Rising out of the flat desert sands in Edwards, California, is a giant metal structure standing 100 feet tall and almost 100 feet wide. It's made of industrial-strength steel that could withstand the harshest winds and rain. This monolith of the desert, located at NASA's Dryden Point Research Center, has been an unsung hero in the life of the Space Shuttle program for the last 34 years. This steel giant is called the mate-demate device, or simply the MDD.
6 inches. You move 3 inches forward and 3 inches out, and that's the only adjustment you have to set it on top of the 747. You can't move it any more than that.
You gotta remember that thing was built to lift 330,000 pounds. See a shuttle up close, you watch it take off on top of that 747 when it leaves here, and it's just amazing. And you know you had something to do with it.
After the shuttle makes its grand re-entry, landing safely while the world looks on, and after the media has shut off their cameras and gone home, a vital, albeit less glamorous event is just beginning. The processing and mating of the orbiter in the MDD. After landings at Edwards Air Force Base, the MDD is used to hoist and attach the shuttle orbiter onto the shuttle carrier aircraft so that it can be flown back to NASA's Kennedy Space Center in Florida. While simple in concept, the execution of this task is anything but. Considering the average landing weight of the shuttle is roughly 230,000 pounds and holds research and payloads acquired in outer space, precious cargo indeed. In addition to mating the orbiter to the shuttle carrier aircraft, a modified Boeing 747, the MDD is utilized to process the shuttle, a week-long procedure that includes taking up the landing gear, attaching the tail cone, and literally battening down the hatches.
They have what they call escape operation, and that's when they do the actual defueling. And the people that are doing the defueling, they have to be in a full suit. It's air-contained, self-contained, everything has its own air and everything. It looks like the spacewalkers.
During the week of processing, the orbiter is lifted about 10 feet off the ground, while crews work around the clock.
That's the basic idea, is to put the shuttle on top of the 747. That whole process involves a week of processing to safe the vehicle to put it on the 747.
Just before landing at Edwards, Kennedy Space Center deploys about 120 people to Dryden to process the orbiter. Together with the Dryden team, this highly specialized team of engineers, pilots, and ground crew work in unison under harsh conditions, performing precision, high-risk tasks with a fragile 100-ton spacecraft.
If you don't do your job and do it right, there's always something that could happen that could lead to somebody getting hurt, harming in the shuttle. So you have to make sure your job is done and done right, and with all the expertise that no one has. So, and that really what keeps you going is the pride in doing that.
Over the years, ground crews were able to perfect the art of mating and processing the orbiter, but never without risk and hardship. To fully appreciate the complexity and scale of this undertaking, it is helpful to understand how the MDD came to be and how it has served as an essential component in the success of the STS program at large. As the sun was setting on the Apollo space program in the early 70s, a new program, the Space Transportation System Space Shuttle, was dawning. One defining distinction between the two programs was that the Space Shuttle was a reusable spacecraft, unlike its predecessor. The shuttle, or orbiter, was to be lofted into low Earth orbit with the energy of 2 solid rockets and the orbiter's 3 engines fueled by an enormous external tank filled with liquid oxygen and liquid hydrogen. Upon its return from space missions, the orbiter would re-enter the Earth's atmosphere, flying without power, like a glider, and land on a long paved runway, like traditional aircraft. These methods of launch and re-entry proved to be very effective. With an extremely short wingspan, and without the expendable external fuel tank used for liftoff, however, the orbiter lacked the ability to take off and fly like a conventionally powered aircraft in the Earth's atmosphere. From the start of the program, engineers recognized that the orbiters might not be able to return to their launch site at the Kennedy Space Center in Florida because of an engine malfunction after liftoff or because of unfavorable weather conditions.
Shuttle can't land in the rain, no. Once it breaks through the atmosphere, it starts cooling off, and there's enough space between the tile that any water penetrating actually hydraulically pushes the tile off of the shuttle. The water doesn't have any place to go, so the tiles are just glued on. That's why landing at Kennedy, always concerned because, you know, how much rain it gets there. Then we're usually pretty dry here.
In this event, a landing elsewhere would necessitate bringing the shuttle back to Florida, which meant the need for a structure capable of lifting the orbiter off the ground and placing it on the back of the 747 shuttle carrier aircraft. Using cranes to lift and attach an orbiter was deemed a far too delicate balancing act to sustain over the course of the shuttle program. It soon became clear that there was a need to build a permanent and reliable structure to achieve this task. Hence, the idea of the mate-demate device was born, and plans to fabricate and construct the first MDD were put into action. The Kennedy Space Center awarded a $1.2 million plus contract to the George A. Fuller Company, a division of the Northrop Corporation, to design and build the first mate-demate device. Soon after, the MDD at Kennedy Space Center was constructed in 1976. In the early stages of the shuttle program, it was especially important to build an MDD at Dryden first. Assembled in nearby Palmdale, California, the first 3 orbiters, Enterprise, Columbia, and Challenger, were actually trucked to Dryden. Once there, the MDD would be utilized for the first time in the historic and groundbreaking Approach and Landing Test Program in 1977. The Approach and Landing Test Program, or ALT, was an essential component in the development of the Space Shuttle program. Used to validate the flying characteristics of the orbiter upon re-entry and landing, and test its systems in flight. The ALT program made use of the MDD for the first time to load and unload Enterprise onto the Boeing 747 in a series of high-risk test flights in 1977. In 1982, NASA arranged to have a permanent mate-demate device erected in Palmdale. The Orbiter Loading Facility, or OLF, was originally built for use by the Air Force at Vandenberg Air Force Base, where it planned to launch a shuttle for its own missions. When the Air Force canceled the plans for a dedicated orbiter and launch facility on the West Coast, the OLF was relocated to Palmdale.
Several years ago, they were doing refurbishment of the shuttles in Palmdale at the Boeing facility, and the orbiter would fly in on the 747, and they would fly into Palmdale, and we would offload it using the OLF, and then we would transfer the shuttle over to the Boeing folks, and they would do the shuttle modifications, and then, maybe a year later, we'd pick the shuttle up and reverse the process, put it back on the 747, and fly it back to Florida.
The shuttle orbits the Earth at Mach 25 and makes its landing at over 200 miles per hour. But when the orbiter finally comes to a halt on the ground, the massive spacecraft is not easy to maneuver. After landing, the orbiter is towed about 2 miles to the MDD, a process that takes over an hour. Once situated in the MDD, the orbiter is lifted off the ground and held there for days while crews work under and over the orbiter, preparing it for its return flight. Because it is not hermetically sealed, the cargo bay is kept at a positive pressure, and the electronics in the vehicle are kept operational. This ensures that the equipment and any experiments on and in the orbiter are kept cool throughout its stay in the MDD.
Anything that's in the payload bay stays there, because on the ground, the payload bay doors aren't capable of opening themselves. They have a special apparatus back at the Cape to hook into the doors to open it. The doors don't weigh anything in space, so they're driven with very small motors.
The MDD is an open truss structure, standing about 100 feet tall, with platforms every 20 feet. A horizontal unit cantilevers 70 feet out from the main tower units, guiding and controlling the sling-back hoist mechanism that attaches the orbiters to raise and lower them. 3 large hoists are used to raise and lower the lift beams. 2 of the hoists are connected to the aft portion of the lift beam, and 1 hoist is attached to the beam's forward section. The 3 hoists operate simultaneously, and they can lift up to 120 tons each. There are 6 stationary platform levels, 2 movable access service platforms, 1 for each side of the orbiter, and other smaller movable platforms.
The old MDD was gray and red. Now if you look down there, it's all gray.
In 2004, Dryden took on the enormous endeavor of removing the lead-based paint that covered the entire MDD. As part of a 5-month process, contractors blasted the paint off the MDD.
The job was huge. There was so much scaffolding and tinting. Once you get a hole in the tint, you had to stop operations. No more blasting until it was repaired, because there was some kind of positive ventilation inside the tent that kept the dust down instead of coming out. We were having, 4, 5, 6 days of 30 mile per hour winds constant.
By adding an ingredient to the blasting material called blastox, over 200,000 pounds of waste material was spared from being sent to a waste management site. Instead, the waste compound was sent to a Portland cement plant where it was burned in a kiln.
It's a zinc finish, self-healing, so if it gets a scratch, it somehow corrodes and turns back into a zinc. It's an amazing stuff. Don't have much to do with launch, but we know we got it back there safe from the last time, so always a sense of pride in everything.
Despite the intermittent landing schedule at Dryden, the The support crew operating the MDD had an astonishing record of preparedness.
I like to think of myself as a good American for doing that. All my guys down there feel the same way, I'm sure.
Yeah, you need to step back at times and realize, wow, this is what I'm doing. It's just a small group of folks that do it.
Throughout its history, the MDD and its faithful crew had a 100% mission success rate over its 34 years of service to the shuttle program.
When I look back someday, I know I'll think of these times and realize just how fortunate I was to have worked on the program. And it's just kind of nice to know that, that you were part of something big.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.